For SEO and having writers post.
Hey guys, Michelle's having some technical difficulties at home, so she asked me to get this going. She should join us shortly, or Eric, are you on? What happened to Eric? He was there for a second. Oh, there's Michelle.
Oh, I made it. Eric was there. You on?
No, Zoom camera.
All right, Michelle, I made you host.
On?
To do that, we had to do it before the first of the year.
So I've been making jokes all along and welcoming everybody, and I've been on mute. So again, welcome everybody. Sorry, my internet was down. All right.
Hey, Michelle, can you hear me all right? This is Scott.
I can, and I can see you too.
Good. I just want to make sure, because I switched off to a different mic this time. So I want to make sure it worked.
You are loud and clear, my friend.
Perfect. Good.
Yeah. Let's wait just a few more seconds. People are still kind of rolling in. Anybody seeing anything exciting on their in their hives while we talk? I'll start it off. I've been seeing my bees all over the dandelions in my yard, and I found out today that dandelion pollen is bright orange. Anybody else see anything? Anybody else got bees?
No, but elm pollen is red, isn't it?
I don't know. I just saw a chart of pollen, and I happened to see the dandelion, and it registered because that's what I see them bringing in right now. Are you knitting, Christina?
I'm crocheting market blanket.
I didn't even know you could do that. How did I
Yeah,
not know that?
I'm a little old lady.
Well, I did know that.
Yeah. I'm drinking tea and crocheting.
I already had my tea.
I will continue having tea until I go to bed.
Let me find the agenda, guys.
Can you hear me, Michelle?
Yes, I can.
Okay. Maybe we could use that pollen chart in the calendar when we do a calendar.
Well, the problem is the only plant I really actually recognized kind of from this area was dandelion. It would be really cool if I knew that all of those plants were actually plants that bloomed here. You know, you see that stuff on Facebook and it turns out it's from Germany.
Maybe we can create one.
I have tried and looked at, you know, something that would show us what local pollen looked like, but I've never had any luck.
Maybe you should stock your bees better.
Maybe I should be nicer to them and they'll let me know, right?
Yeah, just whisper in their little bee ears.
Well, I guess we will start if people keep rolling in. That's okay. We're at 6:35, Sue. Here comes Yvette. All right, guys. Woo, we got a full house tonight. Happy New Year, everyone. Very excited. We have a new board. I'd like to introduce you. We have an agenda with some real quick things to talk about. And then we have a speaker, Ryan. Ryan, are you still Metro and Trinity Valley president?
Great question. I am officially past president at Metro Beekeepers Association for 2021. I am still president at Trinity Valley this year.
Awesome. Okay, so he is a multi-presidented speaker. So I'm the new president. I'm Michelle Burst. I'm very excited to do this. We're going to talk for a minute about some goals for the club. I will tell you that my number one goal is to listen to you. I really want to do what the club wants to do. And to do that, you guys have got to let me know what you would like to see, what you want to hear, give me suggestions. If you're vocal, then you can help me figure out what the club wants to do. Otherwise, I'm just, throwing spaghetti at the wall at that point if I don't hear from you guys. So I'm really hoping to get a lot of communication between us. Speaking about that, we are seriously working on getting MailChimp back up so we can send emails again. I know not everybody does Facebook. The website has been iffy. So I'm really trying to get more than one way of talking to everybody. But that's a little bit of a process, and hopefully we'll get that fixed soon. So our VP is Eric, Mr. Jones. Would you like to do a quick report, introduce yourself? Maybe not. You there? I tell you what, we are going to pass him and maybe he'll come back. Our Christina is our communications, our lovely communications chair.
I don't really have anything. I'm happy to be back. That's about it.
We're very happy to have you back. So looking forward to lots of great bee pictures. Looking forward to seeing you do some stuff on the calendar, almanac, blah, blah, blah.
Absolutely.
All right. Sue is our secretary. She's been our secretary from last year. Sue, can you hear me?
I can hear you, but my internet is down, so I have to have the phone sitting in the window to get the AT&T service so I can run the meeting on my phone, and I'm over at the table taking notes. So yes.
I saw. You're running back and forth. Is that what's happening? Okay. Well, I apologize for that. So we're glad you decided to sign on for another year. Apparently it wasn't so bad last year, so we're excited. Let's see, who else? So we have a new treasurer this year. It's a face that you guys will all remember. It's Gary Barber. He decided to stay on and do the treasurer for us, and we're very excited about that as well. Do you want to do a financial report now, later? I'm putting you on the spot. Yeah.
Sorry, I was muted. Let's do it later.
Okay. Yeah, we can absolutely do
No,
that.
I can do it like here in a second. I just got to find it.
No, let me get through everybody. So we have Sandra is our youth scholarship chair of the committee. She's going to give a little update. Are you ready to do that? You want to go after Gary after I get done introducing everyone?
I'll go after Gary if you don't mind.
Not at all. And then we have Sherry Tuggle, who is now our mentoring chair. And Sherry, are you ready?
I am. Can you hear me?
Yes. I kind of put everybody on the spot. So they're doing great. You guys are doing fantastic.
You're fine. I'm driving, so I just want to make sure you could hear me because I've never done Zoom through my car.
Please don't.
I won't. I have my eyes on the road, not on the screen. Yeah, I have got in contact with a few new members and just let them know that we have mentor and mentee forms available on the website for the mentorship program. So if you're interested in being a mentor or need a mentee, go online, and it's under, I believe, the resources tab on the website, and fill those out. And yeah, we can match mentees with mentors as needed.
Are
And
you-
so, yeah, I haven't had any inquiries yet, but I've just informed a few people. What did you say?
Are you going to have, you're going to need mentors for our youth children as well, right?
Yes, and I believe there
No,
were
we've got
9.
those.
Oh,
We
oh,
have,
okay.
we have those. We have them.
Yay.
Okay, great. Awesome.
Okay, well, welcome. We're glad you you are taking that on, and we're really looking forward to getting that program up and running.
Me too. Thank you. I'm happy to be here.
Yeah, and then tonight we're going to have Scott back to teaching our beginning beekeeper class after Ryan's presentation. If you want to attend that, you can hang out. We're starting from the beginning, right, Scott?
That is correct.
Okie dokie. All right, are you ready yet, Gary?
Yes, I'm ready.
Yay.
Can you make me the host real fast?
Yes. Yes, I can.
Hey, everybody, welcome back to 2021. I'm very happy that Michelle's the president and leading the meeting. And yeah, it's good to see it. Good to see a bunch of new faces on here too. And yeah. So real quick, to just go over the year-end financials, let me y'all see the balance sheet right now? So are y'all seeing the balance sheet on here? Anyone?
Yeah, we can see it.
Oh, okay. All right. Sorry. I wasn't sure that worked. Yeah. So just this is how we ended up the year. Basically, the PayPal has been moved over to the checking, so you can put those together. And then we have so $7,325 total across all of our accounts. And yeah, if we want to go here to the profit loss, we had total income of $5,726 last year. Most of that was dues. Some of that was donations. There was 500 for a youth scholarship from Blue Mountain Community Church, and the others were from some of our efforts, like selling some raffle tickets for the Honda or Toyota and Amazon Smile and the Kroger Rewards are both about the same. They end up being about $30 a quarter, but this is how it's shaken out from last year. I think I've switched them to just donation now. And our expenses were really low since we did everything on Zoom. You know, usually we spend more on hospitality, and we did reimburse some of our master beekeepers last year from the year before, the November test. And the service fees, those are credit card fees from the PayPal dues. And then the insurance we have, the club's general liability policy, it's $1,078. PO boxes 134. Storage, that's one of our biggest expenses. We're going to try and look into maybe seeing if we can't find a cheaper place to store things. Yeah, so in the end of the year, after all expenses said and done, we ended up with a net income of $2,603.41. All right.
So do we have an expense coming up with the youth that I think we have to present to the club and get approved, if I'm
right.
correct. So do you want to tell us what that is real quick?
Well, you know, from last year and years past, we've had a bank account set up. I guess that was money earmarked for that. So it's at $2,936. So that's where that's sitting right now for designated for education youth program. And do we want to talk about the program right now or just the money that's there? It was already allocated. I mean,
Sorry, I was
We-
looking up. Go ahead. Go ahead.
I mean, yeah, is this a good time to talk
I'm,
about
I'm going to talk about it.
Okay, yeah, go ahead, Sandra. Go ahead and fill everybody in.
We have done all the interviews. We had 13 kids apply and one dropped out soon because she didn't realize she actually received live bees as part of the curriculum. And so that knocked us down to 12. 3 did not have their Zoom interview. So we were down to 9. And after sending out the welcome, thank you, you have been chosen, and seeing exactly in detail what they had to do, one has dropped out because she said with her schedule this spring, she's not sure. So we're down to 8. I am still begging / asking for the same budget because I underestimated how much the t-shirts were going to cost. So, but right now it stands at 8. And they're
Additional
all
from
excited. And
the churches, 8 total. 8 is what we have left.
Yes.
I guess talk about the how Texas Bee Supply, through Eric Jones has agreed to donate 9.
Eric Jones did a fabulous job with Texas Bee Supply. They are giving us our jackets for the kids. They're giving us our smoker, our hive tool, and a discount on anything else that we buy there for the kids as far as hardware. Boxes, frames, plasticell.
And the bees.
So they have been more than generous.
Yeah. Yeah, so they're giving the bees. So basically what we're going to have to come up with is the woodenware, and
Yes.
so and that's mainly what this cost is. Is that correct?
Correct.
Okay. Yeah.
And it's, and the fact of it includes the nails, because nails don't come with their boxes, and t-shirts.
All right. Well, yeah. So anyways, this will be our first year to have the have a youth program. We're very excited about that. I mean, it's one of the things that our founders always wanted in the club. So, but this is a at the $800 is more than the board can spend without the club's authorization.
Well, actually,
so
I've got 1,186.42 is what my budget was that I was
Okay.
requesting.
Okay. And so then, so we would have 500 of that would basically was earmarked from a donation from a church that we have to, we have to spend on this. So we're looking for an additional authorization for like $600 for the youth for the youth program. So that would require a vote on from the club to release those funds. So
This is Scott. I move to release the funds.
I would second that. Unless it's probably got to be a general. I don't know if a board member can make a second in the club or not.
This is Andrea Lavu. I'll second it.
Great. All right. So Scott Perry's, do you get that, Sue?
Listen to it again.
I'm sorry. Sue?
Yes, you said it's Andrea.
Yeah, she was
someone?
second.
Lavu,
last-
Lavu.
LAVU. She's going to second. And Scott Perry,
LAV as in Victor, U.
and Scott Perry was the first
Yes,
motion.
I got that. I got that.
Okay, great. Michelle's, she got locked out. Hang on a second. So with the second, I guess, is there any discussion? Anybody got any questions about it before we would vote on it? Hopefully Michelle will get back on here soon.
Oh, and Gary got the books donated from Denton today. So kudos to, and thank you to Gary.
Yeah, I caught Casey on a good day. Well, hopefully Michelle will join us here soon. I mean, I would like to,
So Gary, we ready to go ahead and vote on that?
yeah, I guess we're ready to go ahead and vote. Yeah, I was hoping Michelle would join us back again, but Eric, you're on, right? Is Eric not on either? Jeez.
Yeah, he's on. Yes, he is.
Okay. Oh, there's
Needs to
Michelle.
unmute.
Michelle, we're gonna catch you up. We've got a motion on the floor to vote on approving an additional $600 for the youth scholarship program. So we don't really have any discussion, and everyone's ready to vote.
Awesome. Thank you guys so much.
It's $686.42 is what my current budget is.
Okay, yeah, then we should, I mean, can we add 20% for a contingency to that? And vote on that number? I'm not sure. What'd you say?
Who made the motion?
Scott did.
Scott made the motion and Andrea seconded it. Sue's got it.
Okay, so if Scott will amend his motion to do 20% more. and then
825. Yeah.
If he'll amend that and the second accepts the amendment, then we can move on. Scott?
Looks like he's putting his
Oh.
AirPods on. Scott, got audio yet? No, it didn't work. All right.
I think I'm back.
Okay. Hey, would you be willing to amend that motion to $825 just so we can throw a 20% contingency in there?
I'll lose my speaker too.
Scott?
Sorry about that. I cut off for a second.
Oh, okay, no problem. Yeah, Scott, we were talking about adding a 20% contingency to that. So if you could, that
Okay.
motion would be for
I'll
800.
modify the motion to add 20% to that. Do we have a dollar amount for that?
It would be 825.
825 plus the amount of money that was donated.
Great.
Perfect.
Andrea, that still work for you as a second?
Yep, second.
All right, great. So Michelle,
Okay.
you want to take over?
I sure do. All in favor? I can't see everybody because I'm now on my phone.
How about
So
if we
I'm gonna say-
yes or vote it, chat it.
Yeah, let's just say yes, and then if we have any nays, we can go back. All in favor?
Yes.
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 Any nays? Okay, looks like it passed. Thanks, guys. We're really excited about these kids.
Yeah, I know it's really
Yay!
awesome. This is, yeah, we worked hard to get here. This is really good feeling. And thank you, everyone.
Yes, and then Sandra,
Thank
you said
you.
you have mentors for all the kids.
I do. We are all set up to go. This is so exciting.
And what about like, is there space for anyone who wants to volunteer when we have workshops? Like when we teach them to build their equipment, or when we do, we're going to try and do a field trip up to buy their equipment, that kind of stuff. Do we have room for anyone who wants to volunteer for that?
I will let it out on either Facebook or the club website if we do. We're trying to keep this really streamlined, and this is our first year to go. So we're trying to make sure we don't have too many glitches.
Okay, what I'm trying to get across is we have room for anybody who wants to help. Right?
Yeah.
Okay. And let's see. So did we lose Eric for good? Eric, I saw you pop on.
No,
Are
I'm
you
back.
still-
I just jumped on my phone here.
Awesome. So welcome. This is Eric, our vice president, guys. And you want to say anything, Eric? Talk about some speakers that are coming up real quick.
No, hey everyone. Like I said, we got Ryan on here. Get a couple more queued up for Q1. Blake at Texas Bee Supply is interested in talking with us here in the coming months. We also have a podcast beekeeper, Mandy Shaw out of Portland, Oregon, who's going to jump on. She also makes custom veils. So looking forward to having the guest speakers starting with tonight, and really excited to be able to contribute and see the youth program passed. So thanks everyone, and looking forward to serving everyone in the new year.
Yeah. And guys, I don't know if anyone said anything, but Eric was instrumental in getting a lot of the stuff donated from TBS for these kids. He was able to get equipment and bees and just all kinds of stuff. And that was an excellent job. We're very excited to be able to take on that many kids and get all that donated.
Yeah, totally appreciated.
Okie dokie. So we're going to try and get back on the agenda. We do need to, we have a few positions that are open for anyone who's interested. We need a budget committee, very short term, to put together a budget for us. I need a membership chair and a hospitality chair. They kind of run together. If anyone is interested in either one of those, let me know. You won't have a whole lot to do until we get back to having actual meetings. So that's the committee to be on. So now we need to do minutes from the last Zoom meeting. That would be our December meeting. Sue, I know you have to run across to talk to us. Those are posted on YouTube. And so if someone wants to make a motion in a second, we can approve those.
Can I make the motion to accept them?
Sure.
Since I wrote them. Okay, I make a motion that we accept the minutes from the December meeting.
Tommy seconds it.
Awesome. Thank you. All in favor?
Aye.
Aye.
Anybody opposed? All right, easy peasy. So one of the open issues that we talked a little bit for a minute, is our website and our email. So our problem with the email is login. I'm trying to get that reset with MailChimp so that we can send out emails to people rather than just Facebook. I feel like our communication with the club members, with being Zoom meetings, not being in person, has dwindled so fast, and it was really no one's fault, but I really want to fix that. So that brings me to the good news, and that is that we can now post on the website. So you can go to discussions, you can talk to each other, you can post questions, you can do classifieds, whatever it is you like. We are going to try and get the forums back up so that people can talk more back and forth, and we'll have a moderator on that. And then we're adding pages and resources and links, forms and some stuff to the website. So our main issue was to try to get people a voice back and post. So that is one of my main goals, is to get this website simplified down a little bit so it's easier to transition to the next person who's going to be working on it. Em and Bob have been working really hard on the website to fix these issues. We're going to try and get email. We are going to really attempt to flood you with information. And then as soon as the weather's nice, get everybody back, at least meeting outside so we can see each other again. Some of the other goals, obviously, is to get our youth scholarship up and running. We want to get our mentoring program up and running. I think that's really most of our goals. I know we have some fundraising goals we've been talking about with the club, sort of a calendar and an almanac with photos we'll talk more about that when we get a little further along. Just different things that we can do. We want to get involved with as many people as we can and do as many presentations as we can with kind of the regulations that are going out there so that it's safe. We're working with the city. We are actually working with the city on doing a median. They're changing the medians up to a no-mow zone with wildflowers. And we are partnering, the club is partnering with the city of Denton to work on that. I'm not really sure exactly what all we're doing with that. I just know that it's happening and they've already started and they are considering us a partner. So I don't know. Gary, do you have any more on that to add?
Not yet. I mean, we're gonna try and meet with Drew, the assistant parks director, next week, and try to get more on that. But you know, I know one of the things that Sue's already working on with the master gardeners is identifying native. They want it to be all native wildflowers. They don't want any adaptive wildflowers. So they're I know that's one of their big main drives. And
So the
but other than
question I
that,
had
you know,
was, did they want to just do seeds or did you want plants in there? I mean, and you know, the wildflowers, they're only up for a very short period of time and then they're gone. So
right.
are they wanting just that short time or do they want?
No, yeah, they want stuff that's going to be going off at different times of the year, and yeah, they really want to make it so they don't have to mow that much. That's one of their big initiatives. Is, you know, they're going to do one maintenance strip on the outside and then leave the rest of the median wild. But no, we'll need to talk with them offline because they've already done some stuff with the master naturalists, and so yeah, it's
You know
down the
how
road.
much,
But we really need to talk with Drew to see exactly what participation he wants from us. I think some of it's going to be
can you get me that information before I go to the master gardeners? I've checked with a couple people asking them for plants, but I haven't gone to the master gardeners because I don't really have any definitive information to give them.
okay. When is that? Is it?
Well, I can go at any time. I mean, they have
Okay.
monthly meetings, but I can get the information out to them every week. So
Okay.
I just need
No,
to
it's
know exactly what Drew wants.
right. Okay. Yeah, we're going to meet with him. Hopefully this week coming up. I talked to him yesterday, or next week early, and see exactly what they want and what we can do. You know, hopefully we can do more, but I think they want some groups to take ownership of certain areas or whatnot. So I'm not exactly sure. We're just going to have to hear it from him. So
The biggest difference between the master gardeners and master naturalist is the naturalist will only use flowers and stuff that grow here naturally way back in the early years.
okay.
Master gardeners will use, and master naturalist will not use chemicals.
Right.
Master gardeners are open to doing whatever, a lot of other stuff involving chemicals and bringing stuff in that didn't originate here.
And it makes a difference if you want them to take ownership of it, because all of the projects where they have to do anything in person are on hold. They can't do anything in person. So if you're expecting them to get involved and do an outdoor project, that's probably not going to happen this year. If you just want their input.
The city staff's going to do it. I think they just want input at this moment.
Okay.
Okay, so that's a project that's ongoing, obviously, that we are very excited to be a part of. And so, as I mentioned earlier, I really want to hear from you guys on goals. You guys can think about it. You can email me. You can call me. If you have ideas for the club, things you want to see changed, please let me know. Does anyone have anything right now that they just really would like to bring before the club? I really want to give you some open space to talk. If anyone has anything they want to, any ideas, I really want to hear your ideas.
Well, I just want to say I agree with Tommy and the master naturalist. They will use more native plants and drought tolerant plants. And there are plenty of those that provide pollen and nectar for bees.
One of the groups that's been driving this is the city's integrated pest management work group, mainly as a combat to weeds and other unwanted vegetation. And so, we thought it would go well here and support the pollinators as well. So, and also to reduce the city's carbon footprint without having to mow these areas. Some of them they have to mow 20 times a year. So, and that's where they've gone with the master naturalist on a lot of this planting. They wanted stuff that's more tolerant to the area, that's they don't have to water and so on and on. So yeah, I mean that IPM program was one of the drivers of this with the city. So that's why I think a lot of it's being driven by the naturalist.
So we have Yvette would like to know. Oh, so here's the thing with mead making, Yvette. I'm muted. So we've had mead making presentations on that probably 3 or 4 times. If that is if a lot of people want to see that, just let me know and we can certainly do that again. If you guys think that's a little stale, we can figure a way to make it a little different. You can come to my house, Yvette, and I'll show you. But
Hey.
Whatever everybody wants. If you guys want to see another mead presentation, let me know. There's a lot of new people, and maybe I'm wrong that there's more interest than I think.
Sure. And hey, Michelle, it's Eric. So I know I've kind of put that speaking topic on standby just because it is a frequent reoccurrence. But if we did want to entertain that, there is the mead company out of Dallas that does it on a professional level that we've had a discussion with, kind of possibly considering a partnership where maybe the Denton Bee Club might give some honey and they could do a bee or a mead thing. So there's an option there if we wanted to talk on it from a macro scale of mead making. We do have that, if that would spice things up a little bit.
That sounds like a little bit of a different take. So we can certainly talk about that. So let's talk for a minute about bees. And what you should be seeing in your apiary right now. So tomorrow it is going to be beautiful. And I know that I personally am going to go out and check on my bees. And I am looking for food because now that the queen is laying again, because the solstice has passed and the days are getting longer. So that's a trigger for the queen to start laying. And that means that they're going through their stores twice as fast as they were before, because that pollen and honey is going to be fed to the larva as well as the adult bees. So this is the time where all of a sudden they have a million more mouths to feed. And so they're going to be going through their food. So has anybody else been out and seen, do they feel that they're having to feed their bees excessively? How are other people's bees looking?
Yeah,
I
just
was
before
out-
this, go ahead.
Go ahead. Oh, I was out 2 weeks ago and all of my bees had tons of honey, but I have not been out in the last 2 weeks and they had just started to lay then.
Okay, so yeah, that's something you can keep an eye on. One of the tips that you can do is if you go out tomorrow or Thursday when it's beautiful and you pick up either your super or your deep and you feel how heavy it is. If it feels pretty heavy, then you're pretty good. And you can come back in a week without having to open that hive and just give it a little heft at the back and see if it's lighter. Is it considerably lighter? That's sort of a way you can check real quick without having to open it up and get into the whole thing.
Okay.
Yeah,
I
ours have
wasn't
started
drinking it, you Sue.
ours have really started to hit the dry pollen, and so we're going to go ahead and put some pollen patties on ours starting tomorrow. Just we noticed that they really, before this last cold snap, they really started getting active around the pollen feeders, and so yeah, we're trying to get that early brood, get it built. So yeah, that's what I've noticed. They're starting to be active. Yeah.
I saw pollen on bees last week. I was taking pictures of them, and I saw a few of them had pollen on their legs. So they're finding it somewhere. Anyone have any questions?
Very
Go ahead.
critical. If they're light, yeah, give them some syrup. I mean, they're about to really start to go through the resources once those brood chambers expand, and they're going to have to feed all that young larvae. I mean, yeah, just yeah, I can remember the first year of beekeeping. We thought we'd gone through winter, and then we got to the end of February, and so many of them just died because we just took them to their limit and didn't realize that we needed to keep feeding them. We thought they were good to go for the spring. So very important to make sure they got enough still.
And that food is 1-to-1 right now. In the wintertime, it's 2-to-1. That promotes them to store it up. So now it's 1-to-1. And I put some lemon juice in mine. And the reason that I do that is I keep my pH level below 4 for my food. It seems to be a little closer to actual honey on the pH level. So, and you laughing at me, Gary?
I was just happy to see Mick. I haven't seen him in months.
So that's something that I do to keep my, it just makes it a little closer to honey for my bees. And it's not very much. It's literally like a fourth of a cup for 5 gallons. Anyone else? How's your bees? No one?
We have been doing open feeding for pollen, and they've been hitting it really, really hard. We've been doing the Ultra Bee, and it's like 56% protein, and doing some open feeding. So anyone out there in Corinth that maybe their bees came over to eat in our yard, that's okay too. But they've been hitting the pollen, the dry pollen, pretty hard.
How are you administering that? Do you have, what kind of pollen feeder do you have? Did you make it or did you buy
it? There wasn't anything making, just open on a platter.
Okay, so cool. There's a lot of ways to administer it. Mick, I like the mask. I feel very safe around you.
I'm being safe. Yeah.
You're funny. All right. If no one really has anything else they want to share, any questions about their bees or what's going on or what they should be seeing, I think we can open it up to Ryan. And Ryan, from what I understand, you are talking about mites as a scientific test, correct? Kind of the science of the actual mite.
Right. Primarily talking about mite biology, what they're doing in our beehives, and ultimately what can we do to get in the way.
Cool. Do you need me to make you the host so you can?
Yeah, I will need to be able to share screen, to share slides, if that's all right.
Yeah, that's fine with me. Let me find you. Here you are. All right, I'm passing it over to you. And everybody just remember that if you want to join Scott's class, it will be happening after Ryan does his presentation.
And just so I know, am I on a firm deadline in terms of when I'm supposed to be done?
Are you going to talk more than an hour and a half?
I wouldn't think so. If I start to, by all means, call me out on it. My problem is not getting started, it's getting stopped. So
yeah.
If I'm running long.
Yeah, how long do you think you'll be talking about? What, 30, 45 minutes?
I might push an hour if that's okay.
Yeah, I think so. We'd love to hear from you.
Okay. All right. Let's see how it goes. I also tend to talk slower on Zoom, and I'm a little bit out of practice. So we'll just see how this goes.
Can we have everyone check their mute status? There's some background noise and for the presentation. That'd be great. Thank you.
And I was trying to double check if I can have chat up. It looks like it doesn't want to pull the chat window up on top of things. If anybody wants to try and get my attention as things are asked in chat, feel free. Otherwise, I'll come back and answer questions at the end if they're from the chat window. Yeah, so I guess we covered some of this intro earlier, but for those who don't know, my name's Ryan Giesecke. I'm currently president of Trinity Valley Beekeepers Association in Dallas, where I've been on the board for a number of years now. Still on the board of Metro Beekeepers in Fort Worth as well, but over there as past president this year. And essentially, I run a handful of beehives in Dallas that swells with removal work over the span of the growing season, and then ideally allows me to part with some hives around the end of the season and proceed into the next one. But essentially urban beekeeping experience. And just to be clear, in terms of actual credentials to talk about mite biology, although I have been through the Texas Master Beekeeper program and I do a good deal of educational work, really all I'm coming from in terms of expertise on this topic is a whole bunch of reading. So I did my best to cite my sources as I go through, so you'll know it's not just me making something up. Starting off, Varroa biology and why do we care? Well, as beekeepers, we care predominantly because Varroa mite infestations are statistically shown to result in a lot of colony deaths that presumably wouldn't happen otherwise. Several studies here to try and convince you that this is actually a problem that beekeepers are facing. It is actually resulting in die-off. Basically that's true worldwide with the exception, of course, of Australia, where despite some near close calls over there, they have not yet had an outbreak that actually took off in Australia. And the close calls have largely been Apis cerana, different honeybee that was bringing them in, not the same bees we're keeping, but we'll cover that more in just a second. I am a big picture kind of guy, so I'm going to back off a little bit and talk about mites first. It's easy to say how many mites are in our hives, and we all know we mean Varroa mites, at least most of us do present day. But certainly there's a lot more to mites than that. Mites are arachnids. They live in a wide variety of habitats, around 50,000 species of mites, and that may be an understatement these days. That's an old number, have been described to science, and almost 200 species of mites are found in beehives, according to, again, a fairly old study. I haven't found more recent numbers on that. But the vast majority of mites are harmless to humans as well as harmless to bees, and some are even beneficial. We are talking about Varroa mites tonight, but some of us are probably familiar with tracheal mites as a problem for bees. Largely a problem that doesn't seem to be much of a problem anymore, although it was devastating when it first hit worldwide, as well as when it first hit the US. And some studies have implied that it is hygienic behavior that is preventing these from being a problem present day. It's not like we're all super responsibly and super involved in treating for tracheal mites today. They're for the most part just a non-problem, especially in the southern US. But they are a harmful mite. An example of a fairly neutral mite would be Areoglyphus mites. They're considered pests, damage to stored grain, but in terms of context inside of a beehive, it's just sort of there. It feeds on dead bees, some on other waste in the colony perhaps, but doesn't seem to have any real positive or negative impact on bees. Another neutral to beneficial would be mellitifus mites. They eat pollen, and presumably by eating pollen and not creating any specific problem, they're preventing us from attracting some other problem with that spilled pollen. So we could say neutral to beneficial. Not attracted to bee brood, not attracted to bees or eggs, sometimes phoretic on worker bees. We're going to talk more about phoracy, phoretic behavior, a little bit further into this. And just in case you thought there couldn't be a clear-cut beneficial mite, Stratiolaelaps mites are predatory mites that eat other mites. And these were actually experimented with as a potential control. It looks like I am getting to admit people to the room still. Forgive me if I pause briefly for that occasionally. Stratiolaelaps mites were experimented with as a control for Varroa because they will in fact eat Varroa mites. But naturally they are found in the soil and placed into a hive. They tend to migrate out of the hive as quick as they can back to their natural environment in the soil. So despite a lot of research showing they eat Varroa mites, they're actually not a very helpful control in the real world. And we're going to see that a lot with Varroa mite controls. Creative control approaches sometimes work well in the lab, but not as well in the field. So coming in, tightening up our circle a little bit from talking about mites to talking about Varroa mites. We're still talking in generalizations a little bit, but forgive me, we'll get there. They feed on the fat bodies of our bees. They're discovered in Southeast Asia in the early 1900s. You'll see there S. v. Jacobsoni, which is going to be explained more on the next page. They are originally found on Apis cerana, which is the eastern honeybee, as opposed to the western honeybee that we keep, Apis mellifera. But they did migrate onto a new species, and that's part of why we see such devastation in their wake, is that they moved on to a new host species that did not necessarily have any natural resistances to them. So they have devastated beekeeping worldwide, with the exception of Australia present day. Now, you saw V. Jacobsoni and V. destructor, and the V is just abbreviating Varroa. There are actually a handful of species of Varroa mites, but these bottom three do not matter to us at all. They do not touch the bees that we keep, Apis mellifera, and for that matter, they're not found in the United States. Varroa destructor is ultimately what we're going to be talking about when we're talking about Varroa mites today. But if you go and check some of these resources that I did provide citations for, you're going to find sometimes they're talking about Varroa Jacobsoni. That's not because I made some terrible mistake and failed to notice that. It's because Varroa destructor was first described to science in the year 2000. So as we use some studies from before the year 2000, they will all say Varroa Jacobsoni as though it means what is in fact both of those two top species. Found in the US in 1987, even US studies will say Varroa Jacobsoni for a decade and a half there, just so we're all aware. We're talking about Varroa destructor. Varroa Jacobsoni in theory can be found on the bees we keep, but to my knowledge, it has not been proven to be in the US, and some research has implied that it really doesn't reproduce very well on the bees we keep, choosing to reproduce on Apis cerana instead. So going into a little bit of history on Varroa mites and honeybees and how we ended up in this predicament. It did all start with Apis cerana, the original host for this parasite. Apis cerana is from Southeast Asia, very similar to the bees we're keeping. Multiple layers of comb lined inside a cavity, parallel combs, thermoregulation. In fact, they are managed by beekeepers in their native range. Essentially, they keep smaller colonies, are less likely to be big honey producers compared to the bees we keep. Arguably are better crop pollinators in the sense that as smaller colonies, they don't fly as far. But other than some of these minor differences, they're very similar to what we keep. So it shouldn't surprise us too much that a problem could transmit from these bees to the bees we're keeping today. Just in case you wanted to see them side by side, we can ignore dorsata up at the top. That's the giant Asian honeybee. But we can see our bee in the middle and cerana just below us, slightly smaller is basically the only difference we're seeing. And that's going to be significant here in just a second when we talk about cell size. So before we venture on to how it got off of Apis cerana and on to being a problem for us, I wanted to talk a little bit about how Apis cerana deals with Varroa, because they do have some natural defenses. Self-grooming behavior. This is essentially something we see as general hygienic behavior in our bees to some degree, but arguably Apis cerana is better at it, especially in the context of targeting Varroa mites. They've been documented to have some dance communication pertaining to grooming behavior. Basically, one of the dances they do amounts to, I'm doing the help, I've got a mite on me dance. And that dance encourages other bees to come help groom this mite off of me, which is nestmate grooming behavior. To some degree, maybe seen in our bee, but definitely something that has been selected for since the advent of Varroa mites, and probably that's the reason we see some of it. Mite chewing behavior. This is something that was specifically targeted with the breeding program out of Purdue. I have to admit, I haven't kept up on it in recent years. Last time I looked at it, they were raising mite biters, as they had dubbed them, that were fairly good at chewing mites and not letting them proceed on to the next worker. They were also pretty pricey queens, last I heard, and not necessarily behavior stabilized to go down in future generations. Carrying mites out of the hive. Basically, this is general hygienics again, removal of infested worker brood, again, general hygienics, and we do see it and evaluate it and select for it in various breeding programs with the bees we're keeping. Pores in the cappings of drone cells is certainly something we don't see in our bees, and you can see a picture of it up in the top right. And arguably this lets them evaluate conditions inside of a drone cell better without removing a capping. And we're gonna, again, emphasize here in just a second why drone cells are so important in this situation. If they do see a problem in drone brood, rather than uncapping and tearing the developing larvae out of there, pupae out of there rather, and risking varroa mites escaping as they open the cell, they have a tendency to just propolize the front of the drone cell and wall it all in and let everything die and clean it out at a later date. Arguably a little bit better at controlling the varroa mite situation. Increased swarming absconding, not necessarily something we want to select for in management for fairly obvious reasons from a beekeeper's perspective. And yet it is something that has benefits in terms of varroa mite control. Temperature control of worker brood differs from the bees we're keeping, and we're going to look into the significance of that some as we get a little bit further through this. And shorter worker development. And if I had to pick just one thing that I think makes all the difference, and that I'm constantly baffled why nobody is specifically selecting for, it would be shorter worker development. But we'll touch on more on that in just a second. Just a few numbers here. I sort of breezed by the fact that Apis cerana keeps substantially smaller colonies, but Seeley's numbers versus a 2011 study by somebody whose name I can't pronounce say almost twice, well, 2 to 3 times, depending on the number you're looking at, substantially larger colonies than the bees we're keeping. Seeley's numbers are from the New York area. They may not reflect Texas, but nonetheless, we keep larger colonies than Apis cerana does. Brood development time. I told you I thought this was important, and this will hopefully illustrate why. I cited my sources, except that I don't want to mislead. The red numbers are my own add-in at the bottom of somebody else's chart, giving you an approximate number of foundress mites, reproductive mites that can develop in the timing provided by the cell that it's lined up under. So in Apis cerana worker cells, 0 to 1 based on a 19-day development time, or more specifically, since what matters to a varroa mite trying to reproduce is capped time, we're actually talking about the pupa to adult line as being the significant number here. 11 days of capping allows 0 to maybe 1 foundress mite reproduction. An extra day added to that for our bees bumps that up to 1 to 2 that can reproduce in that cell. Drone cells in both species of bees are a very desirable opportunity for reproduction from a varroa mite's perspective. And queen cells are a dead end no matter how you look at it. The capping time, the pupa to adult capping time, is simply not long enough to allow even 1 mite to reproduce. As a result, varroa mites are somewhat repelled by royal jelly and tend not to be found in queen cells. Bottom is just a post-capping time stimulation study that predicts a reduction of 10% in post-capping times, which is that pupa to adult number, would reduce the mite population growth by 30 to 60%. Very quick, very significant impact on our numbers there if we start shortening that time. Okay. So getting back to our history a little bit, how did this problem get to us? Well, first off, in the early 1900s, around the time this was first documented, these mites were first documented, Russian soldiers are said to have, and there's lots of said to have in history this old, but said to have brought the bees we keep, Apis mellifera, to the Korean peninsula via the Trans-Siberian Railroad, set them down next to Apis cerana hives and the mite jump species, and now our bees have a problem. Before this was thoroughly understood, evidently some of those hives were transported back from Asia into Europe sometime in the 1970s, and thereby provided the foothold for the expansion of varroa mites to what ultimately proved to be the rest of the world, with the exception of Australia. Cell size. I think I got my slides out of order here. Forgive me. I was playing with this slideshow today. This is back to talking about cell size as an impact on development times. But it does illustrate how this jump from Apis cerana to Apis mellifera took place when those bees were brought into the Korean Peninsula. Because you would think different size bees, size matters, development time matters. Surely this Apis mellifera Western honeybee colony looks unfamiliar and undesirable to the varroa mites. And actually what we see on these measurements of these cell numbers is that a drone cell in Apis cerana is almost exactly the same size as a worker cell in our bees. So instead of finding an unfamiliar and undesirable environment, the varroa mites found an environment where they could quite effectively prey on our worker bees instead of being limited to the drones like they are in Apis cerana. And if you doubt that the bees and the mites see them as the same size, if you place our foundation, worker foundation, into an Apis cerana colony, they will use it to draw out drone brood. So no surprise that these mites saw an opportunity there. This does bring us to a minor sidetrack here as we talk about cell size and does it matter. For those who aren't familiar, standard foundation, what we call standard cell size, is actually generally considered an upsize from naturally occurring cell size. Although ultimately bees build comb that is proportionate to the size of their body. Humans used to use a cubit, which I believe was the length of a forearm. Bees do something similar and use their own size to determine how big cells could be, and then the cell size determines how big future generations will be. And so this is all small changes over time, except when we put in foundation that determines the cell size, and then it can happen relatively quickly. For better or for worse, this is something that has become a standard in modern beekeeping. And it is highly debated whether it actually has any relevancy to mite populations. We can find a screen full of studies here. The first one says larger cells have a higher invasion rate. That makes it sound like maybe small cells are good. Second one says more crowded cells actually kill mites. That makes it sound like small cells are good as well. The third one says there's no correlation at all between cell size and mite reproduction. Fourth one says small cells actually have a worse mite population. Now we have complete contradiction going on. Cells that are unnaturally oversized to reduce mite reproduction, says a 2001 study. Lots of contradicting studies, lots of debate on this topic. I do think that the bottom 2 points remain potentially significant. Brood developing in larger cells may receive more visits from nurse bees, which may provide more opportunities for a varroa mite to jump off of a nurse bee, their favorite place to be riding around, and jump into that cell before it closes. Also, and I pulled this from Michael Bush information, he uses historical observations to imply that shorter development times were the norm before foundation was introduced as the norm. Looking back from our present day numbers on what's usually 5.4 millimeter to late 1700s and late 1800s, providing numbers that say emergence was somewhere between 19 and 20 days after an egg is laid, about a day quicker than what we're accepting as the norm today. And about a day quicker in terms of post-capping times, the pupa to adult number right above the red arrows there, is exactly what is working so well for Apis cerana. So I have a hard time completely discounting the idea that cell size plays a role in this. But no way to tell. Do smaller cells help? Lots of debate there. Continuing through our history, varroa mites spread into the US. This is where it started mattering to beekeepers like us in the United States, of course. Came into Florida despite quarantines, first documented on hives that collapsed moving from Florida to Wisconsin in 1987. Early spot checks revealed them already in 10 states, and managed colonies dropped by almost half from 1945 to 1990. Now, I included that last bullet point that I'm going to address first, specifically because I think it's misused in a lot of cases. It's a true statistic, but if we look at this graph of honeybee colonies in the US in that time period, it looks pretty clear that a large portion of that drop had more to do with World War II ending than it had to do with Varroa mites not being here yet, or ultimately with their arrival. So I do think it's a little bit of a misleading number. The Florida to Wisconsin move and early spot checks in 10 states, I think, is real significant because it emphasizes that this was not a march of Varroa mites across the country. If you can't read the small numbers, and you probably can since we're on Zoom, I'm used to doing this live. The dark states got Varroa mites first, and certainly they're not all neighbors, and we're not seeing an orderly march across the country. So how are they spreading? By skipping states? In all likelihood, they're spreading the same way they moved from Florida to Wisconsin, which is with the movement of beehives. And early on, we were especially ill-equipped to address the risks of that. So let's talk a little bit about life cycle of Varroa mites, having covered how they got here and became a problem to us. And I'm not actually going to go through that little spin wheel on this. I'm going to jump into the next slide, and we're going to go through this in a little bit more detail. And we're going to talk about Varroa mites in two places in our bees today. And we're going to talk about traveling Varroa mites and reproductive Varroa mites. And to be clear, they are different life stages, but not necessarily different mites. But let's talk about the specifics of this. Traveling mites, and I did cite Sam Ramsey's study from 2018 on that, and I'll explain why in just a second. But traveling mites are found on the bees. They prefer young nurse bees. I mentioned that earlier. And mites that don't have this traveling stage have a lower fertility. They can skip this traveling stage, which is also a feeding stage, and potentially reproduce, but much less effectively without the nutrients gained from this stage of their life. Now that first bullet point says usually not visible between exoskeleton segments. And that illustrates why this picture, although popular on the internet and great to show you a Varroa mite on a bee, is actually exceptionally misleading and should look a lot more like this. They are between exoskeleton segments on the bottom of our bee's abdomen when they are feeding and riding around on our nurse bees. This makes it exceptionally hard to do a visual inspection of your hive and decide whether you have Varroa mites. And this is what leads us to using young nurse bees for various sampling approaches to getting mite counts in our colonies. And the studies that illustrated that this was actually a feeding stage and not a phoretic stage did just happen in 2018. Sam Ramsey did quite a bit of speaking on him over the last couple of years, and I am using a couple of his illustrations here. He found over and over that the vast majority of them were in a very specific spot on the underside of the bee. A little bit of favoritism, I think it was for the left side over the right side, but regardless, on that same exoskeleton segment over and over and over with remarkable consistency. And this stage was commonly referred to as the phoretic stage as recently as before his stuff was published in 2018. In fact, if any of you have recognized some of these slides from a talk I used to do called Fights About Mites, this does pull some slides from that, and that was put together when we were still calling this phoretic mites. But he told us to stop that. Hopefully you get that from his hands, despite the bees all over him, because phoracy, phoretic mites, implies that there is non-parasitic association going on. They would not be eating our bees. And in fact, what his study showed us is here are anchor points for two hands, if you will, as my illustration on screen does it, and then a piercing hole where mouth parts from the mite pierce into the bee and eat from our bee while they ride around on them. Not phoracy, traveling, feeding. We don't call it feeding stage because they're feeding in the other stage too. And they're feeding on fat body in our bees. This is another thing Sam Ramsey's studies were great at illustrating, is that the traditional wisdom that they were feeding on hemolymph, we could say bee blood, proved to be false. Fat body is not the same thing as hemolymph. It has a lot more in common with liver, perhaps, if we're thinking of mammal functions. And it stores nutrients as well in a way that allows them to be used and indeed restored as they're transmitted from bee to bee. influences all kinds of things, including behavior, by involving vitellogenin in this process. Now, I did provide a couple charts that just illustrate from Ramsey's studies. They are not feeding and thriving on hemolymph. This is how much they're not succeeding at laying eggs and reproducing when they're fed hemolymph versus fat body at the top, hemolymph at the bottom. And the next one talks about the number of days they can stay alive. And we actually see that they're not very far off of starvation when they're fed hemolymph rather than fat body. Really interesting studies if you want to look into that, if that's your thing. But these fat bodies are important because of their involvement in the creation and storage of vitellogenin. Vitellogenin is something that is fed to queens, larvae, older workers. It's something that young bees have and older bees start to run out of. In fact, it's the reason that queens and winter bees live longer, is their intake and storage of vitellogenin in their fat bodies. It's almost accurate to see vitellogenin as the honeybee fountain of youth, if you will, because it's not necessarily a contradiction. As we say, young bees do this, old bees do the other. Young bees are nurse bees, old bees are foragers. And then here we say, actually, vitellogenin-rich bees are nurses and vitellogenin-exhausted bees become foragers. It almost equates to youthfulness in our bees. And in fact, an older bee fed a vitellogenin-rich diet by the rest of the colony can regress to acting like a young bee and being a nurse bee. And in a context where we have an overabundance of vitellogenin, there's a tendency to have some bees pass theirs off and go ahead and become foragers because that's what the colony needs. Very important stuff in a honeybee colony. So jumping off of traveling mites onto reproductive mites. And again, these are all feeding mites. Otherwise, we'd call one of these a feeding stage. Reproductive mites are usually not visible. They're inside of capped cells. So just like we said on the last slide, this picture, great for illustrating mites on a bee pupae on the internet, but a pupal development of a bee should never be occurring here outside the cell laying on top of the comb. We should not be able to see this without breaking open comb and seeing that these mites are under capped cells in our colony. With the exception of sacrificing a little bit of brood, usually drone brood for the sake of a visual inspection, people don't tend to do this, and we tend to rely on the traveling mites to give us an idea how many mites are in fact in our colonies. Definitely prefer drone brood over worker brood. We've already gone through why, and we already talked about their avoidance of royal jelly as well. So now let's get into talking the science of reproduction a little bit. And this word would be much more intimidating if it wasn't one that we've at least had to encounter occasionally as we talk about our bees. Haplodiploid reproduction has to do with males coming from an unfertilized egg, while females come from a fertilized egg. And this is true of our bees in the same way our queen can decide not to lay drones in the wintertime by laying fertilized eggs in all the cells she's laying eggs in. A varroa mite, foundress varroa mite, a female varroa mite, can decide whether to fertilize an egg or not with genetic material she's carrying from an earlier stage in her life cycle. So she lays a first egg into a cell. She climbed in before the cell was capped. She hid in the bee food at the bottom of the cell, not fully consumed yet. She actually raises a little breathing tube appendage so that she can breathe even if she's almost fully immersed down there. And she waits for the cell to be capped. After the cell is capped, approximately 60 hours later, she lays a first egg, and that egg is always male. And then subsequent eggs are almost always all female. About every 30 hours after the 60 hours to the first one. Again, this timing is significant in understanding what measures we can take to interrupt this cycle, and we'll do more on that in a second. Females do have to not only reach maturity before the cell is opened, but they have to mate before the cell is opened. That does mean that in most cases they're mating with a sibling. One more reason not to like varroa mites, I suppose, if you want to see it that way. But occasionally we'll have 2 foundress mites in a cell and therefore get some genetic diversity in future generations. Females may reproduce up to 7 times going through this cycle and lay as many as about 30 eggs on average over their lifetime. Females can mate multiple times with a male if other females do not continue to arrive at the fecal accumulation site where fertilization takes place. Another great reason not to think varroa mites are especially attractive is that their chosen place for mating is the fecal accumulation site inside of the cell. They actually have a feeding spot on the bee, and I think I'm getting into my next slide here, as well as a spot where they use the restroom nearby, and those are the significant spots inside of the cell for those mites. Male mites do have a preference for recently matured females, so there's no, unfortunately from our perspective, no chance of them just liking that first foundress mite so well, or first female offspring so well that the rest don't get mated. They are gonna mate with whoever they have time for. And then the reproductive stage ends, of course, when the adult bee exits the cell, chews their way through the capping, and carries out of the cell the mother mite, the foundress mite, and the mature daughter mites, leaving male and immature females to die in the abandoned cell. And that's an important part of what we're talking about today. But first off, I just want to emphasize how much this means brood presence in a colony impacts your mite situation. Some of us may be attempting to boost brood production through the cold months. Certainly if anybody's doing almond pollination, that's a popular topic there, as you need to make grade for almonds. Some of us may just be trying to get ready for a nectar flow. Lots of good reasons as a beekeeper to boost brood production, but we need to be aware that when we do, we have a negative impact on our mite counts. One study claims mite populations increased 12-fold in colonies having brood for half the year and up to 800-fold in colonies having brood year-round. In Texas, we're probably falling somewhere between that. Let's optimistically call it somewhere around the middle. So, talking about specifics of the timelines in the brood cells. Timing is everything in this talk and understanding these mites. Mites in brood. We talked about foundress mite getting in right before the cell is capped. So there we see her going into a worker cell. Don't be misled by the pink and brown. Brown is female mite and pink is because I was trying not to go quite white, and white is the color we would expect to see in a male mite, and we're going to talk more about that. So 60 hours after the cell is capped, if we remember our previous slide, that foundress mite lays a first egg, and that egg, not fertilized, is going to be a male mite. That male mite is going to live until the cell is opened, and then he's going to die. Because the reason that our male mites never show the same colors that our female mites do, the brown color, is because their exoskeleton never fully develops. They literally do not have an exoskeleton to defend them from the conditions in the outside world. So you'll see an X there where that male mite dies when the cell is opened. 30 hours after that, approximately, the foundress mite is laying some female offspring, starting every 30 hours after that, an additional egg. And again, we'll see a female mite that reaches a mating point for that first bar and is fully mature by the time the cell is opened and proceeds to go out and reproduce in another cell after a traveling phase. Second female mite laid in this cell. Well, she looks like she probably made it under the gun as well. She mated right before the cell was opened. Maybe they got lucky and got 2 female mites in this worker cell. But what we're pretty clear on by the time this third female mite hits is that there's not time for her to mate before she leaves the cell, before the cell is opened. She can't mate after the cell is opened. They don't do it at a later stage in their life, the same way our queen bees don't mate at a later stage in their life if they miss their window. And then on this last one, it probably didn't even have enough time to develop an exoskeleton and be able to survive outside of the cell. So this illustrates a little bit how you can have time to lay more eggs than you can actually end up with viable offspring. And And of course, if we drop the same kind of logic in down here with the drone timeline, then we see why drone cells are so much more preferred and so much more advantageous to varroa mites trying to reproduce in our hives. Plenty of time to get 3 or 4 mites produced in those cells. A lot of this really doesn't apply to anything we do in our hives. Since I was talking varroa biology, I wanted to include it. Protonymphs, deutonymph stages, this is simply irrelevant. It's all happening inside of the cappings, and unless some future means of control suddenly makes it relevant to management, we can safely skip all of this. Simply not going to have any bearing on any beekeeper decisions. But we do need to understand the overall development and reproduction cycle. So for the sake of further illustrating that here, we have the male side first, we have a protonymph, deutonymph, and then a male that successfully mates with one of the female offspring in the cell, becomes an adult but doesn't fully develop that exoskeleton and therefore dies when the cell is opened. On the right side of this illustration, we have a female mite who starts protonymph, deutonymph, and then finds that male mite and successfully mates, leaves the cell and ends up being what was previously referred to and a lot of literature still refers to as a phoretic mite. I prefer the terminology traveling mite for this. And just a reminder, again, illustrated with a mite on a bee's back, that is not where they will be. They'll be on the bottom side, and trying to look for them and tell how many mites are in your colony is like judging how many people live in your neighborhood by how many people are on the sidewalks. It's just not going to give you a valid impression. Ultimately, that foundress mite lays an egg and starts this cycle over in another cell. Just some real pictures. I didn't want to rely too much on illustrations showing you, yes, these are lighter colored. Even the most mature male doesn't quite go to the true brown that we see in mature foundress females. And ultimately a reminder that the males are substantially smaller than the females as well, although it's unlikely to matter unless we're breaking open brood to see them. Implications for mite testing. And I think this is important because this is somewhere I see a lot of new beekeepers getting confused. On the right side here, we are looking down into an alcohol wash photo, which, side note, I did notice somebody had an alcohol wash canister, testing canister for sale on the Denton group recently. If somebody hasn't snapped that up, this might be your reminder to do so. But as we do alcohol wash tests, or if we did a sugar roll test, we would end up in a very similar situation after we dissolve the powdered sugar, looking down, trying to decide how many mites were in this sample. And in this case, we're not looking at a very optimistic situation here, but we need to understand just how bad is it. So with our photos here showing male, immature, female, etc., we're looking at this picture, and what about these little brown dots? They're clearly smaller than the rest of the varroa mites in the photo, but is there any chance that those are immature mites that we just sampled off of the backs or the undersides, more accurately, of our nurse bees? Well, the answer is no. They're the wrong color for immature mites, for one thing, and secondly, all methods of sampling that we're using are talking about the traveling stage or the phoretic stage of these mites. We're not sampling out of capped brood cells. So we should not see any immature mites, even if that weren't the wrong color. Which gives away our next question here pretty thoroughly. Now I'm looking at something that looks like it might just be big enough. Is there any chance that I'm looking at an immature female mite that I just got off of my nurse bees? And again, no, the immature mites would only be inside of the capped cells. So if you're seeing these things that look like, could it be a mite in the bottom of a sample? The answer is invariably no. We're only looking for one thing here, and it is these reddish brown, fully developed female mites. Okay. Getting back into varroa biology, feeding on the brood, I did emphasize that we didn't call the traveling stage a feeding stage, even though they were feeding then, because they feed in both stages. Varroa destructor mothers are actually remarkable at caring for their young. If we were looking for reasons to like them, I guess we finally found one. I can tell somebody's not looking for that. Thank you. But they are pretty remarkable in that they provide a single feeding hole on the underside of the bee pupa, usually on the 5th abdominal scale, again, showing some favoritism here, near the fecal accumulation site, and that allows for travel between the two areas. It's important that the mother do this from the mite's perspective, although not from ours, because the offspring do not have a fully developed exoskeleton yet. And so although female offspring have the same piercing mouth part that their mother does, it is not hard enough yet, developed enough yet to pierce the exoskeleton on this bee. Similarly, the males are unable to pierce the bee and create a feeding site because I don't know if y'all noticed when I had a mating illustration a couple slides back, but I had them face to face for that. That wasn't an accident. As arachnids, they do actually use mouth parts for the sake of passing genetics for reproduction. The male literally does not have the piercing mouth part. His mouth parts are otherwise created to be otherwise occupied. And remarkably enough, even if we end up with multiple foundress female varroa mites in the same cell, they still only create one feeding hole. Presumably, this is a result of selection that resulted from multiple feeding holes creating so much hemorrhaging that it drowned the mites in the cells and was not a viable means of reproduction. Unfortunately, from the bee and the beekeeper's perspective, this open feeding hole and the feeding going on top of it presents another opportunity for infection. And potentially the proximity to the fecal accumulation site is contributing to that as well. Interestingly enough, some studies have found that occasionally a foundress mite or a female mite will not deposit fecal matter on the wall of the cell like she's supposed to, but instead will actually do that on the bee adjacent to the feeding site. And interestingly enough, when that happens, it has been shown to result in or to indicate that that female will not be reproductively viable. Which is the cause and which is the effect, and the hows and whys of that, as far as I can find, remains to be studied, but interesting. And here I wanted to illustrate just how creative people can get as we start to learn the ins and outs and intricacies of varroa reproduction. I'm not advocating for these products. To my knowledge, they are not even currently on the market because one, I imagine cost effectiveness kicked in. Two, I would imagine that they found there were multiple downsides to trying to keep a brood chamber spinning at all times for the sake of discombobulating our immature varroa mites. But the logic behind this idea was that since the feeding hole will always be at the top of the bee, maybe we could prevent developing mites from finding that feeding hole by simply rotating on a regular basis. They couldn't find the feeding hole, they couldn't make another one. Sure enough, all my mites will just starve. Like so many other creative silver bullet answers to varroa mites, this did not prove to play out in a way that generated any success for the idea. Varroa anatomy, again, I'm not trying to go more scientific than actually benefits us as beekeepers. So rather than talking specific parts, I just want to acknowledge on this slide how skilled and how well adapted or designed these mites are for feeding on bees. Varroa mites, female varroa mites, are very well adapted bee parasites. Special appendages, we talked about reaching up and breathing from the bottom of the cell. Special appendages for piercing a bee and creating these holes to create feeding sites. Flattened shape allows them to fit in between those abdominal segments where we know we can find them on the bottom of a bee if we were just examining the bottom of every worker bee. Claws that allow them to grab hold on the bee. And you saw on the freeze, the macro photo from Ramsey's study on the frozen bee that was pulled off, it actually left its claws embedded on both sides of the feeding hole. Even the hairs are designed to anchor them in place in the hairs of the bee and in between the exoskeleton segments on the bee. And not only that, but they even have a chemical pattern that is similar to that of a bee, making it extra hard for the bees to distinguish the mites from being part of a bee themselves. Another just sort of side note talk here, but this is actually the question that I originally started doing research on varroa mites and reading up on varroa mites trying to answer. I had much the impression the general public may get from us sometimes as beekeepers, that I was getting inconsistent data as I asked people how long varroa mites live. And turns out there's a reason for that inconsistent data. It's the same reason we see in giving different answers for how long a worker bee lives. It's seasonality impacting the situation, because the traveling period lasts 5 to 11 days when brood is present in the hive. But it can last as long as 5 or 6 months if we're dealing with a harsh climate, a hard winter, no brood is present. They just keep right on feeding on the nurse bees, on the young worker bees, waiting for the day that brood comes back into the colony. So longevity is determined by seasonality, and female mites living when brood is present in the colony have an average life expectancy of about 27 days, but in the absence of brood, 5-6 months, plus that 27 days ultimately. My own little experiments with finding varroa mites and getting them off bees alive and seeing how long they live outside of the presence of a bee as a food source say that 24 hours would be very optimistic. Without bees to feed on, they are simply dead. Mite population does lag behind bee population in terms of numbers we expect to see in their hive. And this is because although they're both responding to the seasonality, in a way, what's really happening is the bees are responding to seasonality, and then the mites are responding to what the bees did different. So we should expect to see varroa population peak lag behind the population peak for our bees for 2 reasons. One, because as that population peak fades, our bees start allowing population to decline. Even the same number of mites would be a larger percentage at that point. But also the mites are still seeing the benefits of the prevalence of lots of brood right before that. Their population is hitting its peak just behind, which without sidetracking into treatment windows too much, it does make this fall moment a very pivotal moment to assess populations in our colonies. Because not only are the numbers changing as a result of what this shows on this slide, but also remember, this is when our winter bees are developing. This is when our young bees need good, healthy fat bodies full of vitellogenin, providing vitellogenin to help them survive the extended lifespan we expect from them in the wintertime. Very important time to assess levels and have healthy bees preparing for winter. Now, we've talked a lot about mites in this, and it's almost misleading when we talk about mites as the main problem here. Mites are the main portion of the problem that we have any chance of controlling here. But the reality of the situation is that what's killing our bees as a result of mite load is probably less the mites feeding on them and the actual drain on resources in that sense than the impacts of the viral issues brought by the varroa mites. Ultimately, they're the vector for the main problem. They're not really the main problem themselves. So just a reminder, both feeding opportunities in capped cells as well as in the traveling stage on nurse bees provide for transmission of viruses. Without going into too much detail on too many of these, I do want to acknowledge that there's quite a few viruses that are potentially spread by mites. Quite a few of them are potentially spread other ways as well, but much less commonly so. And I believe this is a very incomplete list at this point, but we're talking about only 2 of these today, actually. And those are deformed wing virus and black queen cell virus. And I picked those based on this graph from 2013. USDA-APHIS did a study on virus prevalence in our bees. And although lots of viruses are found in our bees, these came out very clearly heavily on top based on their numbers. With deformed wing virus being most frequently detected outside of this study, but actually shown to lag slightly behind black queen cell according to these numbers. For those who haven't seen it before, that queen cell there does provide an illustration of what black queen cell might look like when you discover it. But we are going to talk through each of these in just a little bit of detail real fast. Black queen cell virus. Essentially, if you're not raising queens, you're unlikely to ever notice this in your colonies. Although it's possible you'll find queen cells that never succeeded in developing properly. Frequently, the workers will go ahead and clean it out before you ever find an example of the problem. Frequently, you might see not every queen cell has the virus, even though the virus is in that colony. And if you're not raising queens, this may kind of just breeze by you without you really needing to pay close attention to it. But if we're looking for symptoms, we're looking for queen larvae or pupae to turn a pale yellow and develop a tough skin, then darken from brown to black. Ultimately, this is hard to see in a capped queen cell, but eventually you may see exterior cell wall appearing dark like something is dead and rotting in there. Although at some point the workers step in and clean that out. Treatment, and I'm using treatment a little bit loosely here because this is mainly just preventative precautions in our management approaches. Sanitation of grafting tools, certainly controlling Varroa and Nosema. It's definitely been associated with Nosema disease as well. Well-fed colonies. And there has been some documentation of antibiotics having a positive impact on this. But there's a lot of speculation on whether that's direct impact on black queen cell virus or actually impact on the general health of the colony in other respects that then allows them to be more resistant to this. Because similarly, we could point to research that says well-fed colonies deal with this better. To some extent, keeping healthy bees helps you keep healthy bees. Deformed wing virus. A lot of current present day research going on deformed wing virus. I've read one study I haven't gotten added to this slide yet. Just came out less than a year ago, sometime in 2020. Validated the idea that what they were trying to study was Varroa mite resistant bees in Papua New Guinea. And what they found is that their Varroa mite resistant bees had quite a few Varroa mites on them, but what they didn't have was any deformed wing virus in the Varroa population or the bee population that they studied. And so what their study ended up somewhat hesitantly concluding was that it wasn't actually Varroa resistance, it was either the absence of or resistance to deformed wing virus that was creating their survival rate. Lots of new research on these types of deformed wing virus. For the moment, all we can say is there are multiple types of deformed wing virus. They are not necessarily created equal, and it is possible for a colony to have multiple types of deformed wing virus impacting that colony. Deformed wing virus can be transferred vertically to eggs when they're laid by an infected queen. A queen with deformed wing virus can give it to her offspring. And of course, it can be transmitted horizontally around a hive, not just through mites like we're talking about, but via infected honey, pollen, potentially even bee feces on frames, things of that nature. It may be an example of the cautionary tales about not feeding honey to your bees because of disease transmission concerns. We frequently hear people talk about American foul brood when we talk about not spreading honey from other hives into our hives. And yet American foul brood is such an uncommon problem in the southern US today. I think it's important to acknowledge other issues tied to that as well. And lastly, although it is easy to spot bees with deformed wings in a colony once you know what you're looking for, and I always tell people you're looking for bees with little white twist ties instead of wings. But once you know what you're looking for, spotting deformed wings in a colony is relatively easy, but it's not a good warning sign for a problem because less than 1% of bees with deformed wing virus display wing deformities. So if you see one bee in your colony with deformed wings, what you're actually seeing is evidence of 1 to 200 bees in your colony that have deformed wing virus based on this study. So opening it up to enough that you can actually see a problem in your hive is a very advanced problem in all likelihood, potentially too late to solve depending on a million things that may otherwise be impacting a colony. Treatment for deformed wing virus is real simple, mite management. There is no approach present day to treating deformed wing virus itself. And that's why we end up falling into generalizations and addressing mite levels versus talking about the viruses that may actually be the root of our problem. Another thing we can look for in terms of visual inspections in a colony, because people always want to look for varroa mite problems when they do hive inspections, and admirably enough, we should be looking for it. We always want to remember mite sampling is what gives us real answers, but another potential sign of a major mite situation is parasitic mite syndrome. You see this frequently abbreviated in beekeeping circles on the internet as PMS, and every once in a while people act like they think it's a joke of some kind. It is not a joke of some kind. It is a reference to parasitic mite syndrome. Symptoms are what we saw in this photo in the background, and now we're going to talk through them. Spotty brood pattern, varroa mites present on adult bees, mites seen crawling across sealed brood, mites in chewed down brood in open brood cells. And hopefully by this point in this list, you're realizing that this is very similar to what we said about deformed wing virus, in that by the time we see these symptoms, we don't have an indicator of a future problem that we need to prevent. We have an indicator of a major infestation in our colonies. Decreased adult population. Wow, yeah, really having major impact on our colony before we see something like that. Sometimes increased aggressiveness. I almost hesitate to put that in the list, but it is something that frequently makes this list with people that I would consider authorities on the matter. I have not seen that with any consistency necessarily. Lack of eggs, developing larvae, supersedure cells, possibly, especially as the colony starts to collapse. They may try raising a new queen and just see if that solves their problem. It's not necessarily indicator of a good defense against this, but indicator that they're at least going to try everything they know to try. And no odor present until decay really sets in. Sometimes with these chewed down cells that we may see mites in or we may not, people start suspecting brood diseases that frequently do have a smell associated with them. Again, if it looks like it's actually been chewed down as a result of hygienic behavior from the bees, that might be a pretty good indicator of a mite problem. And although we're seeing a little bit of a shotgun pattern going on here, if you will, it differs from a true failing queen shotgun pattern in that there are dead developing bees in these empty cells in various stages of getting carried out. Talking a little bit about how they spread so quickly, we touched on this when we saw the map of the US after their introduction. They definitely do spread with help from humans when we move bees around. Despite all preventative measures present day, there's no reason to think that's not still the case. But they would be moving around with or without us too. Certainly absconding colonies and swarming. When colonies of bees move, the mites that are on them move too. Worker drift, we're all told this doesn't happen very much, and certainly if we're watching healthy bees, we see them know exactly where the entrance to their colony is over and over and over. But several studies, and I just referenced one here, have validated the idea that worker drift increases as varroa load goes up. Whether these bees are disoriented or whether they're running from a failing situation, who knows? We can't ascribe too much motivation to bees without edging into fiction. But for whatever reason, workers from heavily infested colonies are more likely to go home somewhere else and act like it's home. Drone movement, drones are always welcome in colonies that they didn't come from, at least assuming the colony has resources to support drones. It's unlikely that we're actually seeing a lot of varroa transmitted that way, simply because they don't favor drones. They favor being on nurse bees, young worker bees. Flower hopping, this photo on the bottom left was stolen from a YouTube video. You can search for that video and find varroa mites nimbly jumping onto the next bee that comes across the flower they're on. Although I will say, I believe for this study, they were placing varroa mites on a flower and seeing if they jump on a bee. I'm not sure I've seen anything that really validates the idea that they would ride a bee to a flower and deliberately jump off. So we have to question how often this would happen. Perhaps most significantly is robbing. robbing is going to play a major role in the spread of varroa mites, and we'll talk about why in just a second. Pulled some generalized numbers from a spread, or I believe it was from a French study that I forgot to reference, spread across France, maybe it was Italy, I forget, somewhere in Europe. The 1 month, 2.5 months, 3 months for various distances are just saying if the colonies didn't move, how long did it take for mites to get that far away into other colonies? So let's talk about mite bombs for a second, because that is what I'm talking about when I talk about robbing situation with that last bullet point. Mite bombs, and I put it in quotes because I to some degree think this is overstatement terminology, but let's talk about what's involved. First off, we have a healthy hive with a reasonable mite count. As the mite count starts to rise, the colony starts to suffer, population starts to go down, reproductive success starts to go down as brood suffers more and more. Before long, the mites per bee is getting higher relatively quickly. Bees are not reproducing very successfully. Mites are reproducing quite successfully nonetheless. Colony starts to fall apart and get robbed out by surrounding colonies. Mites start to get carried off into surrounding colonies. And basically, we're seeing robbers come in the door to a colony that's full of mites, and mites grab onto whoever's available, and some of them end up going back out the door. Before long, the colony is suffering so much from robbing behavior, from mite load, from viral load, that the colony can't support their queen anymore. Colony goes queenless and continues to be robbed more and more. Several studies have validated the idea that queenless colonies are more susceptible to robbing. And before long, even the workers from this colony start to drift off into surrounding colonies. Again, likely to happen with a high mite load, even more likely to happen once there's not queen pheromone telling them to stay there. Before too long, that colony is completely dead, and surrounding colonies are left with much higher mite loads as a result of having robbed resources from this colony. Now, I said I thought this was overstatement terminology, and I would advocate for the idea that we do have to be realistic about mite bombs. It's real easy to take mite bombs as a reason that my problems with my colony are really my neighbor's fault and not my fault at all. And I don't think that's a reasonable message here. We have to remember that all colonies have mites. When we talk about thresholds for treatment, we talk about just the previous slide, a reasonable mite count, I said in number 1. All colonies have mites. I frequently compare them to cockroaches in our homes. None of us really want cockroaches in our homes. And yet, if I saw one cockroach in my kitchen tonight, I would do my best to stomp it, and I would proceed to pretend that my problem is solved. I would not go hire an exterminator to douse my house and make sure and kill all the roaches that might be here, because I'm not seeing them be that big of a problem. Yet I would definitely not gamble much money on the idea that that was the only roach in my house. So just a reminder, all colonies have mites. All houses have some undesirable insect somewhere in them. The question is, do we have a runaway infestation that's going to create an unworkable situation? Since all colonies have mites, any colony that collapses has potential to create a mite bomb. It doesn't really even necessarily have a large bearing on the situation whether mites were the cause for the collapse. When a colony collapses, mites from that colony are likely to get carried to surrounding colonies as a result of robbing. Also, I think we have to acknowledge that hive density plays a major role in how important this mite bomb is to surrounding colonies. If we have one colony collapse under a mite bomb scenario adjacent to 200 colonies that just came back from almonds, well, it may have a whole bunch of mites in that colony, but spread between 200 colonies adjacent to it, it may not be a huge impact on those colonies. If the same number of mites were spread into what was only 3 colonies that happened to be adjacent to this colony that collapsed, we would be far more likely to see die off in surrounding colonies as a result of the mite bomb. But the reality in my mind is that if colony loss rates in your area are anything above 0, then you simply have to have a mite management plan that can weather mite bombs, that can deal with this situation. Any mite management plan that can't weather mite bombs is doomed to failure unless every colony in the surrounding area stays alive. And frequently this is used in the treatment versus non-treatment argument. And I just want to emphasize, I don't see that as a really relevant factor here. What the relevant factor is are we keeping bees alive or not? If your colonies are collapsing every year under varroa mite load or some similar situation that results in mite bombs, then yes, you are worsening the situation for colonies around you. If you are keeping bees alive, I would venture to say that you are not creating mite bombs. And as we talk about density, we do have to talk about general impacts from hive proximity, even outside of the mite bomb scenario context. Some studies, we referenced one from 2016 here, have illustrated pretty clearly that distance between colonies does play a role in what's going on here. Numerous hives in close quarters increases risks of hive-to-hive mite spread, and increased mite spread between colonies swaps selection pressure from favoring parasites that don't kill their host and leave themselves to starve to favoring parasites that can kill their host because they know there's 3 more right next to it. Now, I'm not preaching hard against anybody that keeps hives closer than the 100 meters apart that is illustrated as beneficial in this study. I've asked a whole bunch of rooms full of beekeepers who has multiple hives and doesn't have one of them within 100 meters of another. I've only ever had one person raise their hand to that question. And I'm not doubting them, but certainly they're the exception to the rule. It's an example of where we compromise between what would be best for our bees and what works best for a beekeeper. I'm not saying that is not a valid compromise to make. I'm saying we need to be aware of when our compromises create a worsened situation for our bees, and we need to be ready to do something to improve their situation to balance that. Now we're going to get into temperature impacts here in a second. So I wanted to introduce this concept as we look at mite resistance, overall mite resistance in different breeds, different races of our bees. We actually see Apis cerana, of course, is a totally different species, but Apis mellifera scutellata is the African influence that is part of Africanized bees as we know them in Texas. Apis cerana has nearly 100% infertile mites coming out of their worker brood cells. Again, maybe there's time for one to develop, but not time for it to mate. Excuse me. Scutellata, the African bees, 40% infertile mites coming out of their capped brood cells, worker brood cells. They do in some cases show shorter development times than the European genetics that we tend to prefer in the US. And Apis mellifera in the US, probably largely Italian genetics dominating these numbers. Somewhere around 10 to 20% infertile is about the best we can hope for. And I think it's just important to introduce this concept because we're about to
We don't do Christmas pudding. Y'all do
address it to
Christmas
some
pudding.
degree as we talk about. I think I just muted somebody. Forgive me for that. I was trying to get the background noise out. So again, the average numbers in the US probably influenced by European genetics, looking worse than those other two. So let's go back to talking about swarming, and you'll see how I bring that all back into the picture here in just a second. Swarming and mite load. For a long time, we've acknowledged, generally speaking, that swarming seems to have a positive impact, create an improvement in the mite load in our colonies when swarming occurs. Like I said earlier, we don't necessarily want to select for swarming. It's half our bees leaving, it's half our honey leaving. And most beekeepers see this as a disaster, not a blessing. But clouds can have a silver lining, I suppose. And Randy Oliver, using his magic spreadsheet that some of you may have seen him use in some of his presentations, last I heard was crediting swarming for a 60% mite reduction in the parent colony. That's a pretty substantial impact, especially from ultimately us not doing anything and seeing the bees somehow accomplish this. Now, study from 2005 says, okay, 25% of mites leave with a swarm, but 75% remain in the parent colony, 39% on bees, 36% in brood cells. How do we make those two bullet points not seem in direct contradiction with each other? And I think the answer is likely temperature impacts and impacts on fertility from the swarm process. So let's talk about this a little bit more. We heard a lot of people use the phrase brood break in the last decade or so as we've dealt with varroa mites in our colonies and swarming having a positive impact on them. The idea was that maybe the break in queens laying eggs in a colony was actually what's having this 60% mite reduction impact. And I tend not to like the terminology again here. Brood breaks can be useful windows in which to consider treatments. If you're using a treatment like, say, oxalic acid vapor would be probably the one that I would be most likely to lean towards if I were looking for a treatment that does not impact mites inside of brood cells. Oxalic acid vapor kills the traveling stage, or old terminology, phoretic stage mites. It doesn't impact mites inside of capped cells. So a brood break that creates an absence of capped cells can be a very useful window for treatment. But the thing I would question is, does it actually have a direct impact itself on the mite numbers? And if we look at timing in a parent colony, swarm takes off right around the time queen cells are capped. Worth remembering in terms of swarm management, although I'm off topic, if you have capped queen cells in your colony, it's probably too late to think swarm prevention. Chances are the swarm already left. Swarm leaves around the time a queen cell is capped. And Tom Seeley's research told us that the queen probably stops laying 24 to 48 hours before that. I think he describes it as the workers slimming her down for her flight. And regardless, we can say she tends to stop laying at least 48 hours before her departure from the colony. So that bar I just added there at the bottom is the last egg she laid before she left the colony with a swarm, right? And somewhere over here in the laying resumes window, and I just went for about middle, we'd have to say now that's the first egg laid by the new queen. The new queen comes out, takes her mating flight, comes back to the colony, and eventually starts laying. Laying resumes there. So where is our brood break in this illustration? And the answer would have to be that there does not appear to be a brood break, according to this illustration as it's on our screen right now. So what do we mean when we say brood break, and where is this impact coming from? And my preferred terminology would be for us to be talking about a capping break, because again, the reproductive actions of varroa mites depend on going into a cell right before it is capped and reproducing inside the cell during its capped period. So what really impacts our varroa mite situation is the break in cells being capped. And suddenly we see our very short brood break window, illustrated right there between the orange and the blue in the middle bar there, getting substantially longer as a result of capping break being what's significant here. There is not anywhere for a female foundress mite to go reproduce between the start of that green arrow and the end of that green arrow across the bottom there, capping breaks. Also, there's been some really interesting and somewhat confusing research done on temperature impacts, and even more recently on swarming and how that impacts temperature in a colony. And I'm going to admit that there is what appears to be some somewhat confusing and contradictory numbers here. In fact, you could almost look at some of the numbers for temperature impacts on mite levels and think that we simply shouldn't have problems with varroa mites in Texas, because after all, it gets hot in the summertime, right? But perhaps we can explain some of this, and perhaps further research is needed for some of it. Let's talk through it. Varroa destructor is capable of reproduction in a temperature range 78.8 to 91.4, according to multiple studies, one old and one relatively recent. One study from 2000 showed that Apis cerana is actually defending itself against mites in part by heating worker brood to a higher temperature than our bees tend to necessarily keep it heated to. At which point at 95.9, they're controlling temperature on brood such that varroa mites shouldn't have an ability to reproduce there, at least not very effectively. No longer capable of normal development is how it was somewhat cautiously worded, I think. If the mite parasitizes Apis cerana worker brood, the percentage of infertile mites is very close or equal to 100. So maybe this temperature is playing a role in infertility and not just the timing that we talked about earlier in the presentation. And then we talk about a little bit what happens in swarming. Pre-swarm warm-up stage, 10 to 20 minutes before takeoff, a temperature rise of, and I forgot to convert that temperature rise into Fahrenheit, forgive me for that. But ultimately a temperature rise to up to 95 degrees Fahrenheit, which again, very close to the kind of temperatures we see in Apis cerana brood, certainly above the ideal reproductive temperature range for varroa mites. I pulled some numbers for what bees are capable of, and that's where these colored numbers on bees come from. 94 seems to be a general consensus number for what's the optimal temperature for brood development in honeybees. 104 seems to be the hottest that an individual bee can heat to. So they're certainly capable of getting hotter than this slide actually implies they do. And 82 to 98 degrees Fahrenheit is the number I found for temperatures that honeybee brood can hit without developing deformities as a result of the temperature fluctuations. So definitely some interesting possibilities here. And certainly this is where some of the thermal approaches to treatments have come into play in recent years. Handful of products by various names that center on trying to heat a beehive so as to kill varroa mites. Now I will say that this deformity number here on the bottom right seems to imply pretty strongly that these thermal treatments are in fact damaging and or killing our developing bees. The question would be, is that a good trade-off for what potentially might be a major knockout to the numbers in our mite population? And assuming it is an effective knockdown for our mite numbers, I would have to say I do think it's a good trade-off, even if we are sacrificing brood, even if we are seeing sacrificed brood cleaned out along with the mites in the days following treatment. I'm approaching the end here. I feel like I went faster than I thought I would, and that's probably a good thing because usually I get told I'm going too long. Before we wrapped up, I just wanted to summarize some of the implications to some of what we talked about in terms of survival, in terms of potentially naturalistic or treatment-free approaches, in terms of decisions about treatment, in terms of what are we actually getting useful information from our mite counts. And I want to start by a distinction that I'm again stealing from Randy Oliver on this slide. This was from an American Bee Journal article a few years back, I believe, where he talked about resistance, tolerance, and intolerance, all being methods that our bees could use to solve their varroa mite problem. And they were defined, I'm not sure I used his definitions verbatim, but resistance is the ability of a host to limit parasite burden. So resistance is what we are testing when we test for how many mites are in a colony. Our mite counts, strictly speaking, are a measure of resistance. Tolerance is the ability of a host to limit the damage caused by a given parasite burden. It's possible that the study from New Guinea that I didn't get on these slides yet is actually measuring tolerance to some degree, as they see that survival rates are not necessarily a direct corresponding number to varroa mite counts because deformed wing virus being out of the picture allows the bees to tolerate the mites better. And Randy Oliver also talked about intolerance as a tool that bees can use here. Mite intolerance is exhibited by Apis cerana brood as a path to genetic resistance. Apis cerana brood simply dies much more readily when a feeding hole is poked in it. And in fact, I believe one study said could be stimulated to die as though a mite had killed it by simply puncturing a small hole with a very small needle. The hole to feed varroa mites results in brood death, which results in mites unable to reproduce in that cell. So intolerance to the presence of mites leads to less mites in that scenario. And again, resistance is measured with mite counts. What we see in the background on this slide, for those who aren't familiar, is a freeze kill circle where they have freeze killed brood, and they're actually testing hygienic behavior in that case, arguably a whole nother bullet point worth defining. So just to reiterate, hygienic and resistant bees, resistant and tolerant bees, none of this means mite-proof bees. Mite-proof bees are not something that we have access to at the moment. So don't mistake any of this language. Hygienic bees, resistant bees, tolerant bees, survivor stock, none of it means mite-proof bees. Given a big enough dump of varroa mites from a neighboring colony, any colony could collapse under mite load, regardless of their genetics. But hygienic resistant bees, grooming behavior, brood hygienics, mite biters, measuring mite counts and hygienic testing. Resistant bees would be demonstrating behavior that lessens mite loads. And an ability to survive in the presence of elevated mite counts. I apologize for background noise for just a second, guys. It will be over in about 5 seconds. That is an example of too many dogs in the house. Forgive me for that. I think that got us almost to the end here. Yeah, question slide. So at this point, I'm going to try again to figure out how to pull up the chat window and see if we had stuff popping up in that. I'm not sure why it won't come up for me.
I can look at the chat for you if you want.
That would be wonderful. Thank you so much, Michelle. I can't get it to pull up.
Sure. So if anyone wants to send a message with questions for Ryan, thank you so much. I mean, very scientific, a lot of information. I know that I'm going to have to ponder some of it, but really interesting, Ryan. Thank you so much.
Of course. Thank you for having me. It is definitely a flood of information, some of it more helpful than other parts of it, and definitely some conflicting messages in terms of what we should try to do and what we maybe shouldn't be trying to do in our colonies. And again, my takeaway would be, it's not a matter of what you do and what you don't do. We're all going to do things as beekeepers that have a positive impact on our mite situation. We're all going to do things as beekeepers that have a negative impact on our mite situation. More than anything, I'm advocating for awareness of when we're doing which of those things and thereby how to balance them.
Yeah, I think I found, the mite dump with the robbing to be something I had never heard of. So, that makes you a little nervous, right? When you, have a hive that's being robbed and maybe the hive dies and you go ahead and let the other bees rob it out. That sounds like that's not something we should really think about doing.
Arguably, no. In fact, even Tom Seeley put out an article called Darwinian Beekeeping at one point. He's generally an advocate for treatment-free beekeeping because he has seen feral populations develop abilities to survive mite load. But in his Darwinian Beekeeping article, he specifically says, if you aren't willing to treat for a mite problem, then you should at least consider euthanizing a colony that is clearly on its way out before all the mites end up in your other colonies.
Oh, wow. That's definitely a different way to look at that. That's
It definitely is. And yet, if we were looking at other livestock, I think a lot of us might be inclined to acknowledge that if the situation got bad enough, putting somebody out of their misery might be something we'd consider.
Yeah, it's and when it's a little different when you have 15 hives and you have 2. I do know it's a lot easier to cull 1 or 2 out of 15 than it is to cull 1 or 2 out of 2.
Absolutely. And also, I think that if there's another message behind this, it is we are a community of beekeepers, and maybe my responsibility to my hives doesn't stop with managing my hives. Maybe my responsibility extends to educating the beekeepers around me, because the beekeepers around me understanding the pros and cons to their management does in fact have a potential to come back and impact my bees too. So if nobody heard the unsubtle message there, that message was get involved, support your local beekeeping association, because we are all in this together.
I agree. I agree. Well, it doesn't look like we have any questions that I can see. Can we reach you? Is there an email through Trinity Valley, or is there a particular way anyone could reach out to you if they were interested? I know you're on Facebook.
Yeah, you can find me on Facebook. I will go ahead and pop my personal email into the chat window here. Hopefully everybody can access that.
I
But
see it.
Okay, wonderful. That email should work to get a hold of me. I'm not always super responsive to emails, but I do try.
Well, thank you so much. I'm gonna take this back from you. Again, just a pleasure, and we certainly appreciate you taking the time to come and hang out with us. So, um, I hope you have a well, maybe I won't be able to take it back. Oh, I think you have to give it back to me.
I have to send it back to you, don't I? Let me
Yeah.
get participants up. Oh, I was looking for you by name. There we go.
Oh, Denton Bees.
Yeah. Okay. You should have it back
Awesome.
now.
Awesome. Well, thanks everybody for sticking with us. Scott, are you still there? Still ready to take over and do the beekeeping class? Did we lose him? Let's see if I can.
He looks like he's talking, but I can't hear him.
Oh, okay. So I can't.
Sorry, I
even
had the mic turned off.
No, you're good. You're good.
Okay, so it is if anybody wants to hang around for it, it's the first beekeeping class. Don't feel like you have to hang around. If we all leave, I get to eat dinner earlier. So I'm ready whenever y'all are.
So I'm
We'll
gonna
hang
move
out.
I'm gonna move the host over to you, Scott.
Sure.
And then let you just have at it. Again, thanks everybody for coming, and appreciate everybody taking the time to hang out. Okay, so it's all on you. All right. Thanks.
Okay, thank you. Share screen. Okay, everyone should be seeing my screen now, at least hopefully. And I think I'm on the screen also. At least I can get this set up where I can actually manage it a little bit better. There we are. Perfect. And I see that we still have a few of y'all left. Perfect. Okay, this is the basic beekeeping class. If you get bored, sleepy, or hungry, feel free to leave, because we'll have the same exact thing 3 months from now. Contact information on this slide. If you don't get it now, you'll get it again at the end. So we'll have it in both places. So starting off, let's look a little bit where you get knowledge from. This is definitely not an all-encompassing course. We will not go into varroa mites anywhere near that depth, or any of the other subjects anywhere near that depth. This is a cursory knowledge really designed for a beginning beekeeper, not someone that has years of experience in the beekeeping business. There are lots of places you can get knowledge. When I started off, YouTube was a great one. Denton Bees, the website, newsletters, informational blogs, forums, swarm notifications, classifieds, member directories, find an advisor or bee buddy, or whatever we're calling them now. And feel free to do that. And I'm not sure if this is on full screen or not. There we go. Now it should be on full screen. Goals of this class is really to get you some confidence, increase your understanding, get some hands-on experience, which we're not going to do that now. But when we normally during the class, we'll have times we'll go out to an apiary, increase respect for bees and remarks. And let's see what our chats are doing. Apparently chats are not going to show up with me in this screen mode. Class 1, origin of the bees, basic biology. So if someone has a question, just turn your mic off and ask me. Might be the easier way of doing it, because I think Dan's got a question. Origin of bees, biology, types and parts of the hive, overview of beekeeping tools, and how to get bees. Class 2 is gets more into detail of beekeeping tools, ordering equipment, using smokers, hive inspections, hive management, selecting hive locations, and some basic hive nutrition, which tells into the next one. Gets into pest diseases and problems, bee nutrition, supplemental feeding, and a year in beehive management. Any questions about anything that I'm covering? Okay, cool. The craft of beekeeping. Beekeeping is complicated or can be complicated. If you talk to 100 different beekeepers on how to do something, you're most likely going to get 100 different responses. We all have a little bit of something different that we do, it seems like. And anytime we go to a nice presentation like the one we just went through, you'll learn something new and pick something up from it. And I may do something different than what you do from their own. So there's no single correct way. Find ways and be a researcher and go out and find things that work for you. And then if it works for you, teach other beekeepers about it. So continuously be involved and get involved and develop your knowledge. Bees are not native, or at least the honey bees that we use here, this is not their native range. Their native range was Europe and Africa, which everyone should know by now. Honeybees in the U.S. history, honeybees arrived in the United States about 1622 in Virginia. By 1639, bees were prevalent throughout the colonies. In 1820, honeybees were prevalent throughout the United States. I read a story the other day, and they were talking about, it was an Indian, about the Parker raid down in Texas. And they were talking about the white man fly, which was the honeybees. They knew when the honeybees started arriving, they knew that there'd most likely be white people behind them, was sort of their deal. Now honeybees are not the only type of bees. There's 20,000 or more types of bees: bumblebees, carpenter bees, Africanized bees, honeybees, and many, many, many other types of bees that are out there. But our primary focus in this class is going to be the honeybee, because it's a honeybee class. This is all the parts of a honeybee, and I'm not going to get into them in a lot of detail, just because there are a lot of things in here. But there are things that I would like you to notice on them. First off, hopefully you can see my cursor there, is the crop. The crop is the first stomach in the digestive system. And if the bee goes out and stores nectar, it goes to that crop, similar to that you see with other types of animals that have crops. And then wax glands down here at the bottom, you'll see those here. You'll see the stinger that you'll see back here at the back. And then the eyes and the compound eyes and the antenna and the wings, forewings and hind wings. And I think that is pretty much everything that you'll really need to know or know about during this. The head, the thorax, which is the middle part, and the abdomen. So keep an eye on those, and we'll talk about those as we go through the next couple months. So basic 3 different types of caste of bees that we see in a hive. You've got worker bees, queen bees, and drone bees. And this gives us a little representation of what they look like. Well over 90% of the bees in most cases are worker bees. That's a female bee that's not fully developed sexually. It's a little bit smaller than the queen bee, a little different body shape. It's a little more rounded, and it does have a stinger on it. The wings look very similar, even though the queens are a little bit longer on it. And their coloring lots of times are a little different. You see how this queen bee has a darker or thorax, whatever the one is, I'm supposed to know. But you see it's a little bit darker here on the back, and that helps you spot them a little bit better on that. The queen bee is noticeably larger. It is the largest of the bees. It is longer, and then you have the drone bee that looks more like a brick, and that's the male bee. So the queen bee. Here's a queen bee. This is a research hive, number 58 there in the middle, and then you see the worker bees all around that queen bee. The queen bee has ovaries. You got to look at a beehive as a single superorganism. is a way that you really should look at a hive. Don't look at it as 15,000 or 50,000 or however many bees that are in that hive. Don't look at it as 50,000 individual bees in that hive. Look at it as a single organism, and each of them have a role or responsibility to perform in that hive. A queen can lay 1,500, 2,000 eggs per day, depending on the season. In the wintertime, they may not lay hardly any eggs in the wintertime. They can choose to lay what type of eggs they want to lay. So if they want to lay a worker egg or a drone egg, they can definitely do that. Unproductive queens are replaced by the colony. So they go away and the queen lays a new egg, or the worker bees make another egg and make another queen out of it. She can live up to 7 years, which is extremely uncommon in these days. But if you look at the history, there were bees, queen bees, living for years and years. More likely today, you're looking at probably 2 years. Most commercial beekeepers will replace their queens every year. And that's what I've started doing with a lot of mine is replacing mine almost every year, unless I have a queen that or run out of queens to replace with or something like that. Duties, responsibilities, really 2 major ones: laying eggs and pheromone production. Laying eggs is the reproductive cycle, and the pheromone production is the smell of the hive and keeps the bees organized and those type things. And a good strong queen will have good pheromone production. A weak queen will not. The queen is fertilized in flight, usually the only time that she leaves the hive, and that's just a few days after she is hatched. During this time, she'll be fertilized by 10 to 15 drones. In a given day, a queen can lay her weight in eggs. The queen is fed by the workers. She's busy laying eggs and doesn't have time or energy to feed herself. In one day, the queen can lay an egg every 1 minute, day and night, 24 hours a day. Know that. Worker bees, this is probably the most important. I mean, you got to have the queen, but the worker bees do most of the work by their definition and by their name. They're all females. Any worker bee had the potential of becoming the queen. There's no difference between the egg of a queen and the egg of a worker bee. The difference is how long they were fed royal jelly. Worker bees are fed royal jelly for the first 3 days and then switched over to nectar and pollen and possibly honey, depending on the season and everything else. And bee bread that is fed to them, and not the royal jelly. Royal jelly is a superfood that will make a egg into a queen, a female egg into a queen. Worker bees are switched over to nectar and pollen. Queen bees are fed royal jelly. I guess I've covered all that. Worker bees, during the busiest season of the year, when they're out harvesting and flying around, they'll last about 6 weeks. In the wintertime, they may last 6 months. 90% of the bees in a healthy hive are worker bees. Duties of the worker bees, and they have most of them: cleaning the hive and the comb, feeding the brood, caring for the queen, making orientation flights, comb building, ventilation, packing pollen, water, nectar, honey in the comb, execution, and guard duties. Duties of foraging and worker bees: nectar gathering, water collection, pollen gathering, propolis gathering, scouting for food, and robbing hives. Okay. Propolis, what is propolis? I thought about going back and answering that, but it's in the next slide. Propolis is tree sap. It's mixed with saliva. Propolis or bee glue is a resin mixture that a honeybee produces, mixes saliva and beeswax to gradually exude gatherings from tree bulbs, saps, and those type of things. So it glues up our hive, and they use it for sealing up the hive and keeping it clean. Bees transport propolis just like they do transport pollen on their legs, but you'll notice it's a shiny color and glowing color. Duties of the guard bees: guard the hive. And these are all worker bees. We just sort of broken it up a little bit in what they do. Guard bees guard the hives, make sure the bees from other hives do not come in and rob. These are normally old bees, but sometimes you see younger bees and medium-aged bees in there. Worker bee facts, and just a few general facts about them. Bees live 6 weeks in the honey flow, longer in the winter. leave the hive to use a bathroom. Worker bees determine who the next queen will be. They produce 1/12 of a teaspoon of honey in their lifetime. They visit between 50 and 100 flowers in a day. They collect half their body weight in pollen out in a trip. Only the females sting. Drone bees, male bees do not sting. All worker bees are sterile females. Drone bees, here's our little brick. Male bees make up typically less than 10% of the hive. Their entire role is to take a mating flight and seek out the queen and mate with the queen. They're expendable when times get tough in the wintertime and there's no food around for them to eat. We'll get a little bit into reproduction, and here's a good photographer that got a mating flight in voyage. And the only problem with that mating flight is afterwards the reproductive parts pull out. So they pass away, and that's what you see there. So mating's a one-time event for that worker bee, or that drone bee. The spermatheca is the storage device, or the little thing that the queen stores her semen in for reproduction. And you'll see one that we have here. I went into A&M a few years ago, and we actually dissected queens and were able to look at these. And that clear one over to the left is one from a virgin queen, and the one over the right is one that's from a mated queen that you see in there. So here's a queen that is laying eggs, and that's exactly the way you want to see it. They want to lay towards the middle of the hive, or the middle of the cell. And the egg, when it first is laid, it's standing up, and we'll see some pictures of that here coming up. So here's the beginning of the cycle. The queen lays the egg. The workers feed the hatched larvae. The larvae reaches fully grown. Worker cells are capped. Larvae becomes pupa. Then the adult bee leaves the cell. And that's a pretty simple sample of it. On this one, it gets into a little bit more detail and also gives us the days that it takes required to do each of those in the cycle. So we're looking at a worker bee. We're looking at 21 days for a worker bee to go from a laid egg through a worker cell. And it's very important when we go through this is to look at each of these eggs and see how they're laying. So these first 3 days down here, you'll see the worker is an egg at that point. The egg's standing straight up. The egg is tilting, but not quite touching. By day 3, it's laying on its side. And then it goes over to the larvae stage, and it's in there for 6 days, and then the pupa stage for 12 more days. So if you go into a hive and you want to know how long it was since the queen laid that egg, you can sort of get a good representation of that by looking at the eggs or looking at the capped larvae to sort of see how long ago the queen laid that particular egg. Same thing holds true for drones. Drones take 24 days. And like we heard a second ago, the varroa mites love the drones for that reason, because they take a little bit longer cycle to develop. And then you have the queens that do the same thing in 16 days through their cycle. So feeding larvae, here we are with a young worker bee feeding the larvae. And here we have some cap brood. So here in this picture here, we'll see just worker cells down here at the bottom. We'll see some drone cells that are these that have the curved tops to them like we see here. We'll see some uncapped cells, and we'll see some honey here on the outside. And it looks like there may be nectar in some of those, but I can't really tell in some of those sort of in the middle there. Here is a capped frame of completely drone brood, and that probably came from a queen that was not fertilized, because it's got a very good pattern, more than what you'd see in something else. So this is a hive that's about to fail because you've got a queen that can't lay what you need. She can only lay drone eggs in there, and that's a completely full of drone eggs. Here's what some queen cells look like, different types of queen cells. And we'll get into these and tell you a little bit more about these. These top 2 up here that are laid out in the middle of the hive, in many cases, these are what's called emergency cells. The queen passed away for whatever reason, and they needed to make a queen, so they tucked some cells right there in the middle of where they were laid, and made them into queen cells. Now these up here on the left, on the top, that we see up there, those are queen cells, and those are probably off a queen breeder that you see there, because they're so nicely spaced and everything. Now these bottom two down here, and these are supersedure or swarm cells down here, that we see down here at the bottom. And the queen probably laid these, and the bees drew them out down here on the bottom of the frames, and the same thing for this one over to the right. Here's a little mix mash of a little bit of everything. It's not a very good looking frame, but you sort of get everything there in the picture. You've got a good bit of drone brood out here on the outside. You've got some worker brood cells here in the middle, and then you've got some queen cells scattered in there. If you had a frame like this, you've got a mess, and hopefully those queens, whenever they hatch out, they can do a little better job of whipping this beehive into shape. Hive. So there are many different types of hives that can go with. There's two or three, I guess really two, that we're really going to talk about the most. The first one would be the Langstroth hive that we see here. And the second one will be the top bar hive that we see here. The rest of these hives are variations of these two here. This is what they'll see over in Europe. And these hives down here, we don't use them here in the States, but they do use them in some other countries. And I think they're called skiff hives on it. Every time I do it to this slide, I keep forgetting what that one's called.
Can I ask you a question?
Sure, absolutely.
Before we leave the discussion about the longevity of the bees, I'm really curious about here in Texas. I'm new beekeeper here in Texas, but I'm curious about you know, the amount of time it takes for the winter bees to essentially be changed over to new worker bees in the spring. And the reason I'm asking that question is I had a very, let's just say a very nasty hive last summer that I requeened at the end of the summer. And the queen's there. She made it fine because I checked weeks later and she's in there. But, you know, I'm sure what I'm still dealing with is a lot of the original bees are hanging in there as winter bees. And I'm hoping, though, that her genetics will start to change the hive in the spring. So I was curious, what could I expect as a longevity of those winter bees in terms of that change?
What month did you change out the queen?
Oh gosh, it was probably September, October, somewhere in there. It was late.
Okay, so you've got a couple months in there where they may have been laying brood, and they're still going out and trying to collect nectar and stuff.
Mhm.
But yes, you probably have still a good bit of genetics in those worker cells and those worker bees that's going to hold over until probably March. Here in Texas, we, depending on the year, January, February, you'll still definitely have some in there at that point. But by March, you will see a lot of those have thinned out.
Okay.
And what really affects the longevity of a bee is them wearing out their exoskeleton. As they flap their wings and they make little microfractures of their exoskeleton, and it just wears their body out. If they kick back and sit in a chair on a recliner or laid in a bed all day, they last for a lot longer, years and years.
Yeah.
But it's just really all the work of going out and gathering the nectar and pollen during the growing season that really limits it. So
these were surprisingly aggressive, you know, and someone said your only answer is to requeen. You've got to get the genetics changed. And so
yeah, and that's a good answer.
Yeah,
and that's a real good answer for that.
Good.
Thank you, Mark. Anybody else have any questions while we're here? Good. Okay, Langstroth and top bar hives. Langstroth hive is really made up of a lot of different parts on it. I was talking to Michelle today, and we were just chatting about this subject right here. if I was a new beekeeper and I just wanted to have 1 or 2 hives, would Langstroth be the way that I would go? And honestly, I don't think it would be. I think I'd go with a top bar hive if I never wanted to get more than a couple of hives, just because there's a lot of expense and a lot of work to get one of these hives up and going, and equipment to extract and those type of things. So let's start off at the bottom. There's some kind of stand, and we'll look at those. Bottom boards, that is the bottom of the hive. You've got a deep box. That's called a super there, but that's not really what it is. It's a deep box. Or a brood box. It does not have to be deep, but that's where the brood is going to be laid, is in that brood box. There's what's called a queen excluder, and we put those on. We're trying to keep the queen out of the honey production. And then we've got what's called honey supers, and those are boxes above the queen excluder where you want them to put honey. Now, these are shown in this picture as shallow boxes. They don't have to be. They could be any depth you want them to be. And this has a telescoping lid, so you've got an inner cover and a telescoping lid on this. So we're going to go by each of these parts here. Here's another picture of it, a little bit more in real life. So there's a deep box here, a deep box here. Both of these are brood boxes. This is more like what I would do in my operation. And then a medium box or a honey super setting on top. You can see a little metal strip there. That's a queen excluder. Now for the stand, there's cinder blocks down here at the bottom. I've got mine up on wood beams or metal stands or something else like that. There's all different options to choose from there. So let's talk a little bit about options when you're getting ready to get in the beekeeping business. There's lots of options you can go with on deciding what type of equipment you're going to use. There are hive bodies in honey supers come in 8 frames and 10 frames. And then what's called a nuke box that comes in 5 frames. Most people do not use nuke boxes for honey production. They'll use it for other reasons, but typically not honey productions. Now, the vast majority of people use 10 frame boxes. There are reasons why you may choose to use an 8 frame box, and it really has to do with weight. A full box of honey may weigh 80 pounds. That's in a deep 10 frame box, and it's sitting further out from your body. And it makes it harder to lift. So if you have back issues, if you're getting a little older, if you're a lady, you may choose not to want them to lift a big heavy box. And limiting the size of the box as far as the number of frames that'll fit in it is a good way of doing that. It's about 20% lighter, but it's a lot easier to manage or to lift than a 10 frame box, because that weight's pushed closer back to your body when you're lifting it. Hive bodies come in 3 depths: 9 5/8, which is a deep, 7 5/8, which is a medium, and 6 5/8, which is a shallow. Most beekeepers do not use a whole lot of shallows. They're a little harder to manage because the bees fill them up quicker, and they're just as much work to extract as one of the other 2. So commercial beekeepers, in many cases, will run exclusively 9 5/8 boxes, both for the honey and for the brood. Amateur beekeepers, a lot of them will run medium-sized boxes to eliminate some weight. It's a shallower box. It's a couple inches shallower, so it makes it less weight to carry. If I had a back surgery, I may go with an 8 frame box and just use medium frames in there. So that would take off a good bit of weight out of it. And you take a box that's maybe 80 pounds full of honey and maybe cut it down to 40 pounds worth of honey in it. So it saves a good bit of time or a good bit of weight on your body. Frames. This will go over a little bit on some of the frames. If you have a Langstroth box, you've got to have Langstroth frames to go in it. And that's what this is. They make different types ones, wood ones or plastic ones. Most people use the wood frames, and they have a choice here on the foundation in it. But these are the basic parts. You can get them unassembled or assembled. If you get them unassembled, you'll need to nail them together, and that'll be coming up in a later slide. Now, the top bar hive. Top bar hives are easier to build. It's fairly simple. I can go to Home Depot and get this material here to build this top bar hive fairly simply. And it doesn't take a lot of craftsmanship. On the inside, you've got a bar that's coming across with some type of wood hanging down or some kind of strip hanging down for the bees to make their comb onto. And this is what it looks like when it's finished. That's turned upside down. This is a nuke box for a top bar hive. There's less parts to it. It's easier to build. To extract it, you don't need a big honey extractor. You can take it and crush it and squeeze it through a cheesecloth and get honey fairly easy from a single frame. So there are some advantages to having a top bar hive. Now keep in mind, there's lots of disadvantages to having a top bar hive also. It doesn't produce as much honey, but it does produce more wax. When you just harvest honey from a top bar hive, you destroy the wax foundation. So they have to rebuild it every time. Another advantage of a top bar hive is you get new foundation every time. So diseases are less likely to be an issue in a top bar hive because you're circulating through your foundation and putting new foundation in it, or you're cutting it off when you harvest. So there's lots of other advantages and disadvantages. If I just wanted one hive for my garden and I didn't want to have to worry about borrowing or buying equipment to extract, I would seriously look at this. Top bar hive. Some basic beekeeping tools. You need a veil or a suit. I highly recommend a suit just because of what Mark was talking about, having an aggressive hive. I get stung through my gloves at times when I have aggressive hives. You go out there on a cloudy day or the weather's changing and those bees will get after you. The other thing that you need is a smoker, hive tools, feeders, and those are the basic tools that you will need. Now there's lots of other tools and we'll get into a lot more of that, I believe, next month. Getting your bees. There are lots of ways to get bees. Most beginning beekeepers buy their bees. But there are other options. You can purchase packages of bees. And I just got an email today from one of the beekeeping companies that they had package bees they have on them ready to sell. And they didn't have nukes, it didn't look like on the email, but they had packages ready to be shipped and sold. The other one is a nuke. A nuke is a small box of bees with frames in it, with foundation in it, with a queen in it. It's laying eggs. You have eggs, brood, and larvae in there. It's just not in a full-size box yet. The other choice is to collect a swarm. A swarm is a natural reproductive system of a beehive. They got overcrowded. The queen decided, hey, it's too crowded in here. The bees decided that. They laid a new queen cell. The old queen flies away with the half the bees or whatever, and they go form another beehive somewhere. But when they leave the cell, they go land in a tree or on a wall or something else, and you can go get a box and stick them in a box and take them home and put them in your hive, and they may find it a nice home and just choose to stay there. If that's something you want to do, you can definitely get involved in it. And the club we have a swarm board where people put swarms in there, and that's mainly in the spring. So this is what a package looks like. 3 or 5 pound package is what I normally see. Cost $150. I should have looked at it today. I didn't. What the cost is. It seems like every year they go up $150 to $200. They're good bees. There's nothing wrong with them. It's just they don't have the eggs, larvae, or foundation in the box with them. It's just the bees and the queen that you have in there. But if you have a top bar hive that you want to try using, this may be the way that you get your bees, because you don't want to have Langstroth nuke box that you have to figure out how to get into a top bar hive. So you can purchase a hive or a nuke. A hive is a fully functional beehive ready to go, and the nuke is just a small one of the same thing. So it has queens, bees, larvae, pulled frames, unknown temperament or depending on where you get it. If you're getting it from a reputable beekeeper, hopefully you're getting known temperament. If you're just getting it from an individual, you may be unknown. It's available whenever the beekeeper is selling it. I see people selling bees. This time of year, they're relocating. They want to take their bees with them. You can go over and pick them up. You can get on Craigslist. You can swap with other people in the group. Texas Bee Supply. We've got a bunch of other suppliers. Typically in the spring, there'll be people there in the club selling it. Cost $180 to $340, and I think $180 is probably a little bit on the low side. I'm not sure what they're selling them for this year. but every year they've went up quite a bit. Catch a swarm. And that's just finding a swarm that's out there. Someone notified you about it. A lot of water companies will have you go through and get swarm or ones out of meter boxes. And those are not really swarms. Those are normally cutouts out of a water meter box. I've done it, and I'll let someone else do it. About 50% from my experience abscond. That means they go away. They're typically available March through April. Join a local beekeeping club to get on the list, advertise on Craigslist. The state has a website. The cost is typically free on it. Where can you purchase bees? Sabine Creek Honey Farms, Texas Bee Slide, Bee Weaver, R Weaver, Tractor Supply, and then there at the club, there's always guys selling bees there at the club. Any questions?
Okay, so a quick question.
Sure.
The 50% abscond, that's interesting. I guess I wouldn't necessarily expected that. Any sense of?
That's 50% abscond from a swarm. And that's my experience from it. And not just my experience. I've got a guy that he removes bees for a living. And that's what he told me. He says, we stick them in there. He says, part of it's gone, part of them don't. There's ways to improve that percentage. If you'll put some brood in that box with them. Some people close them up. Some of them put a queen excluder on the front. There's all different things you can do to help improve that. But the bees may not like to be where you've got them. They may want to be somewhere else, and they do abscond.
Okay. Yeah, the temperamental bees I was talking about were native bees that I had gotten, that a guy had, captured, and just you could really tell the difference. So.
Oh, yeah. Yep. Any other questions, Mark?
I think I'm the only one alive here. So.
I understand that. I've been teaching this class for years. I thought when I first started teaching it, I'd teach it a month or two, everyone would be educated and I could retire. But here I am years later, still teaching the same thing over and over. And I thought, I've got them all taught. But nope.
Well, I appreciate it, Scott.
No problem. Well, you have a great day, and let's wrap this thing up.
Okay.
As soon as I figure out how to shut down this meeting. Aha. I think I've got it. Stop sharing that and end. Y'all have a great day. Bye.